early on this Sunday. It's way too late for a Saturday. And by bright and early, I mean that I woke up bright and early and then goofed off for 3 hours. Or 4 hours. Hey, guess what? Did you know that Twitch uses cookies? By continuing to browse the site, I'm agreeing to the use of cookies. I'm logged in. I have no idea what they're going on about. Alright, okay, so I'm live now. So tell the world. I will be building planets today. Moons. Fiery planets. Whatever I can think of. Game dev stream for ProcGen. I might be a little bit raspy because didn't get much sleep, but hopefully that won't interfere with my ability to make planets. I mean, you don't need to sleep when you're making planets, do you? So we'll head on over here and post it as well. And then we'll head on over here and get started. Alboechi is here. I think Alboechi just never sleeps. So, yesterday we created this randomized green planet, this garden planet. There's lots of other planets that we need to make, and this isn't our final take on the green planet either. But we definitely need to do a couple of things. One thing I want to do is create the bump maps. Malsbeer is here as well. Everybody's here all of a sudden. But you know what I've forgotten how to do is create bump maps. Create bump maps. Code. Creating a bump map shader, normal mapping. There's code for it, but I don't remember anything about it. A normal texture looks like this. That's not what you call it. It's a bump map, not a normal texture. Well, I guess you can call it that if you really want to. So what we need to do in order to turn a height map into a normal map is the question. I guess I should look that up specifically, shouldn't I? Turn height map into normal map. I better spell that right. Height map into bump map. I don't need a video about it. I can go on without it, but my planets are looking a little bit flat right now. I would like to have them look a little bit more good. How to convert from a bump map to a normal map. That's the opposite of what I need. I know I found this code before. It was just really, really straightforward. Now I can't find it because my Googling is weak. I presumed it would be very, very easy, but it's not. Maybe it's because I'm not actually really awake yet. I've only had half a cup of coffee. I don't want to generate a height map from a normal map. I want to do the opposite. Oh, well, whatever. Elbow says, can't I just apply the height map to the bump map? I mean, they're basically the same. They're just handled differently, right? Well, no. The height map is a grayscale image that shows the height of any given pixel. In this case, it's the alpha channel that matters. Whereas a normal map has all that blue, red, green stuff to show how the normal gets offset. The bump map shows how the normal gets offset. And that allows me to, say, have these mountains shine in the sun. If I turn on the tint by height, I kind of get a fakey version of it, but the problem is that that fakey version of it screws up my ice caps and stuff, so I don't need it like that. I need to have it be better. I'll leave on the tint by height for now, though, and we're going to go ahead and cut down our pixel size so that we can start work on other kinds of planets. This is all stuff that's going to change later on, but for now we'll go ahead and drop this entire Earth-like planet into our prefabs list, and then we're going to create a new planet. Elbow says, oh, normal map, not bump map. Well, I don't really care what I get as long as it's that red, green, blue shit that I can use for bump maps. Fmelsbeer says you need it at runtime. Well, I need it specifically to process an image I'm creating at runtime, so I don't know how I would do it any other way. So this is our Earth-like planet. We're going to go ahead and just duplicate it. Well, I guess we don't even have to duplicate it. We'll just save it as something else. We're going to go ahead and make a moon-like. And our moon-like planet we will save separately so we don't accidentally overwrite our Earth-like. The moon-like planet is just going to be a whole new set of these manipulator objects, so that should be fun. So first off, we'll create a basic foundation for it. So we'll go ahead and call this the foundation object. Now I'm going to go ahead and pull up pictures of a moon. So if I am a little bit slow on chat, it's because I'm looking at the wrong tab. But basically, what's mostly notable about any kind of lunar image is that the surface of the moon, while it's pockmarked and cratered, usually has very distinct albedo. So you'll have like a really dark mottled area, and then you'll have a really bright area. And I think that that's mostly age of crater impacts, but I'm not sure. Now, the other problem with the lunar impacts is that although everybody keeps telling me that I don't need to do it, the blast marks that go outward from any lunar impact, they're really noticeable. And not having them is going to feel pretty bad, but I don't have any choice. I can't think of a good way to create lunar impacts, short of having a texture to do it. That's actually not a bad idea. I could create a fairly high-quality texture, and then basically just copy the texture over as a noise pattern. I could just create a lunar crater with streaks. That might be an interesting choice. Elboechi is talking about whether there's a difference between bump maps and normal maps. I don't really care what it's called. It has to be the thing I can put in this slot labeled normal map, which used to be called bump map and is now called normal map. I don't really care what it is, but it is the thing that has the red, the green, and the blue, and those represent tilts along various axes, right? That's very straightforward. I just don't remember how to calculate that shit. It's like mostly just a matter of going across and subtracting the pixel from the left and the pixel from the right and stuff like that. Yeah, they did change the name to normal map. I didn't realize that. In the older materials, it was called bump map. Maybe that's why I'm having a hard time looking it up. So I will go and create the impact crater texture. I think that's probably something I should go ahead and just do. So for that, we're going to just start up the art program. There it is, art program. Let's do some wrangling. And how big? I think 512 by 512 is probably about right. There we go. And let's get to doodling. Let's draw ourselves a crater. Yeah, there we go. So what we're going to do is we're going to use the transparency here aggressively. So this white background is going to actually be transparent. And what we're going to do is we're going to draw in a crater. Now, craters are round, as you might expect. And so what we're going to want to do is create a round impact. But what we're going to need for this is it's going to have to be a height map. So when we think about that, what we really need to do is draw the places where it is going to be lower and higher. And because of that, we're going to make this paper a neutral gray, just so that we can see it. Fine, we'll make this layer a neutral gray and we'll hide the paper. What's going on? Why is this taking so long? It's a 512 pixel image. Did I accidentally tell it to be like 1,000 pixels or something? Or like 10,000 pixels? No, it's 512, so why is everything running so slowly? That's really weird. Look at how slow that is. Did I... No, that's not... I'm not still running there. This is weird. This shouldn't be this slow. It should be snappy. It's quite a small image. Anyhow, what we're going to do is we're going to create a nice wide impact area that is raised up a little bit, because that's how craters work. You have the detritus that flies around everywhere. And then we'll center that a little bit. And then we'll hollow it out just a little bit, because that's a little bit too bright in some areas. And we'll just make the outer edge really, really soft. Probably could have used a spray paint for that, but whatever. And then what we're going to need is to darken the inside. And black will be low, and otherwise, it'll be high where it's brighter. So we'll just create a crater like this. And that will be our height map for our impact crater, more or less. But what we really need here is a bunch of streaks, because the streaks are what actually matter. I can crisp up this impact crater any way I want, but it's when I get to the streaks, those are almost impossible for me to get using noise, which is why we're going to be using this. That said, however, I think that this is still a little bit soft. So we're going to go ahead and just use a finger brush in a widening spiral to sharpen up these edges. And I still don't know why this is running so badly. I wonder if my computer is getting scanned right now by my protector or something, because this is really, really slow. Abysmally slow. I've never seen this art program run this slow. It's generally quite fast. So then what we're going to do is we're just going to create streaks. And we can create streaks however we want. But if we look at the actual streaks that are on the moon and stuff like that, they don't go like this. There's streaks that are inside and there's streaks that are outside. So that's what we're going to create right now. We're going to go ahead and just, on our own layer, create a variety of streaks. We could use a brush for this. In fact, there is a brush built right into our default palette. Oh, it's not even a brush. It's down here, isn't it? It's burst and dense saturated lines, these guys here. So if we were to create these like this, well, that might be too many. I want fewer lines than that. Can I get this to be a gap of line? Oop. Okay, that's more like what I want. So we'll go ahead and... I haven't used this very much, so I'm not 100% sure how it works. That should do. Then what we'll do is we will erase at the edges so that we don't have any sudden stops on these lines. They need to just peter out. And in a moment, we will go ahead and erase much more aggressively to make some of these lines disappear, because there's still too many lines. That's decent, I suppose. And we can add in little details, because these are places where debris actually stops. We'll go ahead and turn on the hard eraser and just erase some of these lines completely, because there are way too many lines as it stands. So we'll just clear some of these guys out. That's more like it. And then we'll just decorate these other lines very, very gently so that they feel a little bit like they're bouncing and as they move along, because that's kind of the point, right? And if we've got the high enough detail to add in these details, we absolutely should. There we are, just a few details here and there. And then what we'll do is duplicate this layer, cast it to a wider line, which we can do by doing filter, correct line drawing, width, thicken width by 2. And then we can lock it in and paint it black. Now, as you can see, that ended up creating a really, really dark layer. So this layer here is being drowned out by the copy. And the reason for that is because this has a very low transparency. I drew very lightly. But if we change the transparency here, we can change the overall transparency. I didn't expect it to be this difficult to get right, but I guess I used a technique I wasn't familiar with, and I ended up doing some slightly odd things. If we duplicate this, and then we can get it a little bit better, and then we can take this and change it around a little bit just to try and get these to feel like that. We can drop this down and reduce the overall weight of those. That's fine. Now for the interior, I'm going to go ahead and draw its own set of scrapes and marks, because these are supposed to be a little bit less obvious. They're not as regular, they're not as long, they're a lot less structured. So we'll just draw them in freehand, and don't forget to put in some scrapes. And then the debris that piles up at the edge of the crater will make for a nice detail. Sounds like my neighbors are getting noisy. Well, hopefully you won't be able to hear that. And then what we'll do is we'll just lower the density on that as well. And maybe a little bit brighter. And then we'll save this whole thing to the correct file. Shouldn't the streaks lower blacker than the rest? No. Here's the thing. It doesn't really matter to me whether the streaks are white or black. But in this case, raising them up is actually easier because this is going to be damn near zero height. Up here, the streaks getting raised or lower is largely irrelevant. I guess technically speaking, I should probably make them darker throughout, but I like the well, we'll see. I can always change it later. But I have to save this, and I actually don't know. Hold on a minute. I have to switch monitors for a second. I'm going to switch to the Phoenix Wright screen. Yay! Give me a moment here. Yeah, I thought so. We'll go ahead and grab the location here. And move it here, drop it here. And then we'll save it here as crater. Oh, I forgot to turn off the background layer. What the heck? Whoa, this art program is moving really slowly. I don't like this. Even when I'm not recording this screen. Oh, this is weird. I may have to bounce my machine. Are you done? Can I kill you? Because you are taking up all of my damn time. Look at how long this is taking to save. It's a 512 by 512 image. Jeez. Anyway, we should now have two new files, a broken one and a non-broken one. This broken one, I couldn't save over it, because reasons. But this one should work. All you need to do is turn on the alpha. Oh, there it is. Alpha is transparency. Whoa, why is everything taking so long? This is really weird. I wonder if I burst a memory leak open. Unity's been acting strange recently, and it may be that I have a massive RAM leak, and it's gotten out of control. How is this file 2048 by 2048 now? Well, that is a fascinating question. I've been working in millimeters. Okay, that explains why it's been so slow. Okay, now I can accept this. Well, since I drew it at that height, I might as well change it to 1024 by 1024. Good catch, Elvoechi, because that was obviously the issue. So now if I turn this back on, can I still, yeah, I can still see the streaks, so that's fine. That also explains why the lines weren't behaving in the way I thought they were going to behave. So we're going to go ahead and save this as the crater. That was nice and fast. I forgot to turn off the, oh, I didn't, that's good. And then what we'll do is we'll turn that alpha transparency back on. And now it is 1024 by 1024, which is larger than 512, but substantially smaller than 7000 by 7000, right? Right. So what we need to do here is use this as a source for a new kind of noise. Let me go ahead and put away all of this art crap. Move my mouse and my mic and get back to work. So what we're going to need here is a new kind of noise field. And it's going to be a texture noise. Texture noise. Come on, chords, behave. All right. So what we're going to need to do is descend from texture proxy. Texture proxy? Yeah, I think that's what it's called. And we're going to be basically the same as our basic noise. So we're going to copy most of this noise down, but we don't need the noise source because it's going to be a texture. We can use the scale and the offset and this stuff. All of that stuff we can just take. But what we also need to do is have a public texture 2D source. We don't actually, I'm not 100% sure we'll need an offset. Whatever, this should all work. The problem is that right now we're not sampling anything, so we got a couple of overrides we're going to want to work with. Now, normally what happens is we use this, which has the index of the destination pixel, and then the planet position, which is going to be our source pixel. Now, the problem with the source pixel and the destination pixel is that there's a lot of stretching involved, and I'm not 100% sure this is going to work out, but we'll give it a shot. So what we're going to need to do is grab the correct position in our source texture. So we have the index for the destination. We now need the index for the source. And to do that, we're going to need to take our planet position and convert that into a pixel coordinate. And so to do that, we're going to need to planet pause. We'll go ahead and not modify the planet position because we actually use that for some stuff. Go ahead and call this source x equals planet pause dot x times scale. And then source y will be the same thing, but for y. The z is the absolute value of the x-axis. We're going to go ahead and just leave that alone for now. And what we need to do is then have an offset. The offset is something that normally we use for noise fields. But in this case, what we would do is we would use it to move the stamp around on the planet's surface. So in order to do that, we could just add it in. Let's go ahead and see how that works. I'm a little bit concerned that that's not going to work out because we have this issue where the proxy, the image, is only a one. It's mentally speaking a 1-by-1 image, right? There's the bounds of what we're looking for go between 0 and whatever the maximum is. But once you work it out, it's 0 to 1, both x and y. If we have an offset, then obviously any offset that takes it out of that 0 to 1 position will end up removing it from the map entirely. But we do want to be able to have an offset. So I think what we'll do is we'll go ahead and make this divided by 100 instead of times 100. Just to see whether or not, well, maybe not even divided by 100. Divided by 2 is good. Just to see whether or not that works out. So now we have the S and the Y position, and we'll just need to convert them over into a source pixel index, which is going to be mathf.floor to int sx plus sy. Oh, no, just separately, otherwise we'll get drift. Times source.width. Easy enough. And once we've done that, we can grab that source pixel. So that's source.getPixel, and we can just grab it at any given point. Now keep in mind that grabbing a pixel here may actually be quite slow. I'm not sure. It might be easier for us to load up all of the pixels and then manually just grab it from a list of pixels, because otherwise we're using getPixel over and over and over. Yeah, I'm 99% sure that getPixel is slow as hell. I'm also 99% sure that I have to change this creator over into a read writable. There it is. So what we're going to need to do is have a list of all of our source pixels. Protected, color 32, source pixels. And then down here in process, we're going to go ahead and load it up if it needs loading. So if source pixels dot length, so if source pixels equals null, then source pixels equals source.getPixels32. We'll also do it up here in randomize. So down here, we're going to go ahead and call this source pixel index because we have something called source pixels now. And then we'll say color 32 source color equals source pixel index. That's pretty straightforward. Now, there's no skewing on that side of things. The skewing is all on the other side because this planet position, I think that the X has already been adapted. Well, we'll know for sure real soon. So once we have the source color, we then can print it to the target, but only at the alpha that it's being shown to us. So float alpha equals float source color dot alpha divided by 255. That'll get us an alpha between 0 and 1, and then we can use that as our volume. If alpha is less than or equal to 0, it'll never be less than 0, but whatever, return. So otherwise, we're going to want to lerp between our color and the destination color. So color 32 target color equals get channel index planet. Hold on. If alpha, oh, that doesn't really matter. I was thinking about optimization, but it was premature. I don't need to worry about that. So we're going to grab the target color, and then what we're going to do is we're going to make our source color equal to the lerp between the two colors. We could use an overlay. I guess we should do that first, right? No, let's go ahead and ditch the overlay for now. We'll go ahead and just do it straight up. Alpha literally can't be less than 0, because a byte can't be less than 0. So we're going to go ahead and say that our source color is going to be the lerp between these two. And I think we've got the access to the lerp. The lerp, byte lerp. I know I have a color lerp. Or do I byte lerp with each color? Now, hold on, let me see here. Oh, here's add colors, subtract colors, and keep our channel. But none of those is the color lerp. Color 32 has a lerp. Okay, I don't need to build one then. Oh, Java has signed bytes. That's dumb. Fortunately for me, I'm not working in Java. So we're going to get target color, source color, and then T, which is going to be our volume alpha. Lastly, we're going to want to make our source color.alpha equal the target color.alpha. And that way we won't have to worry about accidentally changing the alpha layer when we don't intend to. The only reason that might bite us in the butt is because if we are... oh, wait, we're targeting a specific channel, right? So really we're going to just do a keep our color here. We'll just copy that. So, well, what we're doing is we're using alpha. So we're actually only going to be taking one of the channels from the source. And we're going to go ahead and keep red. But our red is going to paste to whatever channel is in play. So if we were going to have this as our color, for example, the only part of our color that matters is red. Their color is what changes after that. And so we'll just go ahead and change this to R. And then down here what we're doing is we're grabbing the source pixel. We're grabbing all of the elements, red, green, blue, and alpha. We use alpha to determine how much we need. But after that, we only are going to be using red. Now, here what we're doing is we grab the target color from the channel. Get channel isn't a target color, is it? Get channel should be a float. Okay, so hold on. I've botched this a little bit down here, so we're going to go ahead and start over. This is going to be float target color equals get channel, channel index p. And then what we're going to want to do is have our float height equals source color dot r divided by 255. And then what we're going to do is we're going to set our source color, our height rather, to the lerp. So mathf dot lerp target color height alpha. And then our last step is write our height to the proper channel. And then we do a switch channel. We don't need this keep our channel stuff. Just delete this. And then we'll just do a case target channel dot height. Then we will set channel. Oh wait, we can just do set channel. We don't have to do any of that. Cool, cool. Set channel. Then we'll pass it our channel and the index and the planet and the new value of height. And that should let us stamp texture noises anywhere we please. The only question is whether or not the math about placing the texture noise is decent. So source pixels, I forgot to make it an array. There we go. So that might work, maybe. Let's find out. We're going to go and put a new texture noise here. We're going to drop in that texture that we created. and we're going to go ahead and stamp it out onto the height. We currently don't allow for noise map remapping in here, or height map remapping. We'll have to add those in later. For now, let's go ahead and comment those lines out so that we don't feel like we're using them when we're not. Oh, sampling didn't work. If source pixels equals null, or source pixels dot count dot length is less than index, less than or equal to index, then get the pixels. So this should work. I'm an idiot. I actually was going to put in the capping, and I completely forgot. So if sx is less than 0, return, or sx is greater than 1, or sy is less than 0, or sy is greater than 1, return. Then we'll say sx, we need to actually make these the correct width. There we are. That should work in theory. Let's see. Oh, what a fascinating result you've given me here. And the reason for that is because there's a lot of leftover noise from earlier sampling that's not being cleared out properly. So we're going to go ahead and just try and run this moon-like planet here. There, that's what I expected to see. And you can see that what we've got is a rather badly stretched impact crater. So I'll probably have to redo the impact crater in order to make these lines a little bit better. But right now we are working at a very low level of detail, so, you know, whatever, right? But you can see that it's really distorted, and I think the reason for that is because the x and y coordinates are not as unstretched as I would have liked them to be. I think I've got to stretch the x and the y coordinates by the same value that I'm stretching them normally. So over here in Texture Proxy, I don't do any of the stretching, I think. Oh, Planet Pause. So here in Planet Pause, we actually do stretch these values. We're going to use the exact same stretch amount. But it is a situation where we do want to be a little bit more careful. We actually store the stretch amount. So hold on. Px is the stretched x value in planet position. Py is the y value, which is just between 0 and 1. And raw x is just, so we're actually trying to use raw x, not p, so we want to use the z channel. I got which channel was the z channel backwards. So we'll go over here and we'll switch out this x for a z. There we go, much better. And you can see that that's a lot less distorted. It's always going to be a little bit distorted just due to the nature of what we're doing. I can probably distort it even less if I want. But the thing is that this here is very low. It's very low grain and it isn't smoothed, so it ends up looking kind of spackly. Now if we were to increase this to a more requisite size, you can see that you do get the streaking, but it's not really very sharp. It's very grumpy. It's got a lot of pixel problems with it. Moreover, we never actually end up rotating this or anything. So the question is, do we want to try and blur this this map so that if it's scaled differently, we do blurring? Or would it be better for us to draw the map with the idea that these are going to happen anyway? Moreover, we're going to want to spin these. We're going to want to have this be a random rotation. So I guess what we'll need to do is just apply that spinning value at the end. So public float angle offset. And then down here, we'll go ahead and say angle equals random dot value times 360. Down here, when we need to rotate the SX and the SY by a certain amount in order to get that angle to work, the question is, do we do that before or after we offset it? And I think we need to do it before, because otherwise we'll end up being in a weird place. The problem is that when we rotate it, we're rotating it around 0, but the values are going to be between 0 and 1, which means we're going to end up rotating it off into a quadrant that doesn't get covered. So if we wanted to fix this up better, we would want to subtract 0.5 from each and then rotate them before we even get started. So that's what we're going to do. So oh, in fact, they already are. These are between -1 and 1, so they already are correctly rotated. That's good. Correctly rotatable, rather. And then here we'll replace this with SX and SY. And what we're going to want to do is rotate by angle. So how do you rotate by the angle? Well, that's not too difficult, but I can't remember how off the top of my head. I think I can just call it with sine and cosine, but there's something about it not going across quadrants correctly if I do that. Let me just go ahead and Google it before I make a dumb mistake for the next 20 minutes. Rotate point by angle. So I was right. I can just rotate it by the sine and the cosine. So float sine equals mathf.sine angle. Float cosine equals mathf.cosine angle. But more than that, I can actually cache those, so we might as well. Protected float sine equals 0 and cosine equals 0. Sine equals mathf.sine angle. Cosine equals mathf.cosine angle. That way we don't have to calculate it out every time. And then we can just say that Sx equals Sx times cosine minus Sy times sine. And then Sy. Okay, so there's the problem. I actually need. That's what I was thinking about. I actually need to do this in separate steps here. And then Ry will equal Sx times sine plus Sy times cosine. And then here we'll just make these Rx and Ry. And in theory, that should rotate by a random amount. So if I were to randomize this, it might vanish entirely because we are offsetting by some arbitrary amount, and that offset might be stupid. For now, let's go back into this and change the offset to 0. I broke it. I had a feeling I was going to. That's interesting because this shouldn't have really broken anything. Let's take a look at the debug here. Sine and cosine are both set up correctly. But I don't think that we have any printed values here. That's really weird. What if we change the scale to 0.5? I might have just been really lucky about getting this to actually appear the first time, because it's not really appearing anywhere on the map as we speak. Let's go ahead and reduce the size of this map and see whether or not we can cause a debug to happen. So debug.log chords sx plus sy plus sx plus rx plus ry. Well, it's doing all sorts of weird crap. Oh, that's fine. Whatever. I'll live. And then we'll go ahead and plug this in here. And then we'll plug this in here. And then we'll go ahead and down here put in a source pixel. So debug.log source pixel index. Oh no, I'm about to sneeze again. I should have taken my antihistamines before starting the stream. Great. Right. So if we run this now, we should get a bunch of messages. There we are. And here what we can see is that our offset coordinates are constantly outside of the allowed realm. I'm trying to decide why all of our y coordinates are negative 0.46. They're not always. They are. They're always negative 0.46. That's really strange. So once we've scaled the coordinates, we end up with the same values over and over and over. And the problem is that our rotation seems to be moving all of our y coordinates down to being negative 0.9. Let's go ahead and reduce the amount of chatter we see so I can debug that and see whether that's the case. So you can see that what we've got is a set of coordinates that slowly marches along, and the results here are that when we're rotating it by a certain amount, we always end up with negative values. Now that is fine for half of our setup, but the other half should be positive. You can see that we're slowly climbing here, but we're still at negative 0.3, negative 0.2. Okay, so negative 0.1. So these numbers are correct. And now we're positive. So the question is, what happens when we become positive, positive, right? There, positive, positive, chords 0, 0. Source pixel 0. So that happened and that worked. But here we have another source pixel 0. Is the problem simply that all of our source pixels are going to be 0? Well, let's go ahead and change some of these offsets. First off, we're going to offset by something that will always drag us into a positive value here, or 1, 1. We're going to go ahead and make the scale 1, and we're going to make the angle 0. I guess that doesn't matter. That doesn't actually work. It's going to remain 90 regardless due to the caching. That's fine. Array index is out of range. Source pixels index. That's interesting. Source pixel large. Okay, that's interesting. So there's something going on here where our source pixel calculation is a little bit screwy. Might be this. No, it busted. So what we've got here is a source pixel of something atrocious. So let's go ahead and see what it thinks is happening here. No. Clear. There we are. So our offset coordinates are 1, 1, and that's the problem. We are literally at the maximum possible value for our texture. So what we really need to do is, rather than trying to get the coordinate at 1, 1, we need to return it. I just forgot that. That's just an off by 1 fence post error. That is fine. So we'll clear this. Clear. And then we'll run it again. There we go. And what we end up with is a bunch of source pixels and stuff like that. So we definitely wrote, it's down there, you see it? So let's go ahead and clear off our debug logs, because they are going to get real loud as soon as we start to bring the numbers back up. Save that. And then what we'll do is we will just raise the width to 512 by 256 and see how we like that. Yep. So that works fine, aside from the fact that the streaks are not large enough to really see very well. I might redo the texture later. It doesn't really matter at this point. But what we can do now is, when we re-randomize it, we can see whether or not it's something where it's not going to ever pop up on the surface, because obviously it should pop up somewhere. We can see some streak. We can see like a streak that runs off into nowhere, but we don't actually see the impact. And there it is. So it looks like it sometimes works and sometimes doesn't. Now, one of the issues we've got, I don't know if you've noticed, but it's always being stretched on the x-axis by twice as much. So what we need to do is change the x-axis so that it's twice as large. There we go. And now it should always be circular. Oh, we got 2 of them this time, because we bounced off of the 0. It looks like we may always have it mirrored, which would be dumb. So how does this work? So this is x of negative, and this is an x of positive. I don't know how it would just bounce. That doesn't really make any sense. So we take the planet position and we multiply it by 2, which would make this, oh, that's a 0, so that's very close to not being multiplied at all. Certainly wouldn't invert them. And then we rotate around the 0 point. And then we scale by whatever our scaling is. In this case, it's just 1. And then we add in our offset. So I'm failing to see how that could possibly end up with a mirror. That's super weird. How would that end up creating a mirroring situation? I really don't understand what's going on here. I really don't get this. This is so strange. Because there's really no reason for it to mirror. Oh, except... stupid me. I actually have it mirroring on purpose. The core x value has an absolute value attached to it. So what I actually need to do here is if planetpause.x is less than 0, sx times equals -1. And that should prevent it from mirroring, but it should also mean that the change I just made doesn't seem to be popping up very often. So there it is when we end up, there we are. So now we're no longer mirroring. Great. Works pretty well. There are lots of things I can do to make it different. We're going to need to redraw it for starters. But if we just duplicate this a bunch, oh, well, they're all at the same setting. There we are. We get a bunch of overlapping impact craters. Now, right now, all of them are the same size. We could change the size and then just have like a bunch of different impact crater scales. But really what we need is a way to generate a few huge craters that that dominate the space, and then we can use the simpler craters that we create using a noise field to fill in the rest. So if we do that and we change this scale down to 0.5, for example, and then we run this, okay, so why is this not? Okay, so that's about the right size. And you can see that we end up with streaks and stuff. So if we were going to do that, what we could do is we could do 2 of those, and then between them, we could do a crater hits. In this crater hits, we could use more classical crater hitting techniques. So instead of using a texture noise, we'll just use a standard noise, basic noise, and we will just go ahead and use our triperlin, because that's got more heights, and we'll subtract a channel from height. Our scale can be, I guess that's probably fine. And then we'll want to have a noise map that has a cratery feel, and that means that we want to have a sharp dip. That might be a little bit low, so we'll just move it up a touch. There we go. And if we do a sample on that, you can see that these are the noise patterns we're going to get. And then if we just run it, we end up getting some weird looking donut style craters. Let's go ahead and restrict ourselves a little bit more, because that's not very pretty. There we go. So then we got a bunch of random impacts, and that's pretty decent. But we don't really have the density of random impacts that I want. The problem is that crater impacts don't happen all over a moon. I mean, they do over the course of time, but they're focused mostly on specific areas of the moon. So what we really need to do for our crater hits is use a channel that is not the one we're actually looking at. So right now we got a problem where our offset is screwing us up, and I think it's because if the offset is less than 0, it doesn't work. There we are. So now we've got some craters, but we don't have nearly enough craters, and they're not focused. So what we're going to want to do is our crater hits are going to want to be focused on a specific coordinate. So we're going to use a channel crusher. So we're going to want to use a channel crusher to create a new channel clearer, rather, to create a crisp new channel, which we're going to call the red channel. Then we're going to apply this to the red channel. We're going to make it addition rather than subtraction. Now the channel clearer currently sets it to 0. We're going to have it set it to a specific value. Because I actually want to clear it to 0.1. Or 0.2, something like that, right? Just so that we can get the ridges on these properly. So what we actually need here is, clearing it to 0 is fine now that I'm thinking about it. Because what we need is a basic noise that creates a soft set of higher areas that we can work with on the red channel. That's definitely not the noise I'm looking at. There we are. So if we do something like this, we should be able to get a nice sort of feel. And if I were to change this to this, it should be a little bit better. Yeah. And that way we'll have specific areas that tend to get hit. Yeah, like that. And those areas are the only ones that are going to matter for us. Now the problem is that right now, when we do basic noise, we can only apply ourselves to the same channel that we're drawing information from. So that means that when we're drawing from the red channel, we end up printing to the red channel. So if we're going to do that, then that's going to make it a little bit challenging for us to then return that back to the planet. If we write this back to the height map, we're going to end up with raised areas that get hammered down. But to tell you the truth, that should be fine. Let's find out. So if we then add in the triperlin noise, we can restrict it to only things that are above 0 height. And now, if we turn on our height map, we should see the red channel. Oh, the red channel gets overwritten, doesn't it? All right, so we're going to need to print it back out into the height map. So I'm going to take red, print it to height, and add it in. All right, so what the problem is we've got here is that I've somehow managed to invert the craters. There we are, better. And so now we should have craters that only hit in a certain part of the planet. Now I can't make the triperlin noise any denser than that without risking some dumb stuff. So what we're going to do is we're going to copy this component and paste it in a couple of times. That's not cheap because each of those is 3 calls per pixel, but that should be okay. And you can see we're starting to get something that might look not too bad. I think that what we're going to want to do is have another set of crater hits that's different. This is still not going to be great, but what if our crater hits did different scales on their triperlin noise? That would make more sense, wouldn't it? That's an interesting crisp line. Look at that. I bet the texture, it doesn't wrap properly. Okay, so what if I changed the try Perlin subtract noise map to be more forgiving on this guy? But I also made it not quite as tall. I'm trying to get a noise field that feels like it dominates the space of the moon. That's definitely more like what I had in mind, although it's a little bit too aggressive. So, well, what happens if we change it over just to Perlin? It's definitely more like what I had in mind. All right. Just move this a touch to the right because that's a little bit too much. And then let's run this. Run! All right. So now what we're going to want to do is actually have it paint us some dark spaces where the craters get hit. So to do that, we're going to use this basic biome. And we're going to tell it to paint in some darker regions like this. Not quite that dark, like this. And then we'll have it be a smoothness and metallicity of 0. And we're going to apply that to places on the red channel that are 0. Hold on. The problem is that the red channel is not... When the red channel is positive, those are highlands. So those aren't the places that we want to draw. But if the red channel is 0, that includes all of the moon. So that's a little bit strange. Let's go ahead and try it. Let's see what happens when I paint all of the moon. Okay, so you can see that what we have is a set of spaces that is quite strange looking. But the only thing that is bright are the highlands that we have created. And the highlands have these strange crisp edges due to our basic noise here. So what we're going to want to do is actually drag this up to above that basic noise to the top here. Now what we've done here is we can paint the highlands specifically. So let's go ahead and create some nice bright highlands. And then we'll change the fundamental planet color to something dark. So you can see that we've got these highlands now. But the highlands aren't the places that are actually being cratered. Oh, because I forgot to invert this. Let me sneeze into the mic. Okay, so now the highlands are the ones being painted, and you can see that the craters that happen on the highlands are going to be darker colored, but that's not going to be good enough. This is not working out. So let me think for a second, and let me look at a picture of a moon. Moon. Yeah, so this is not really what I want it to look like. I really, really need this sort of mottled, blotchy flavor to it, and this crater is not working out. So we're going to go ahead and start over with a new set of cratery objects here. And we're also going to hide these so that we can work just on the craters at the moment. Because what I want out of the craters here is a blotchy, splotchy situation. So if I use the tricolor noise or the triperlin noise, that should work. Let's go ahead and just try it here, sample. So you can see that what we get at the triperlin noise is a very blotchy flavor, but the problem is it's blotchy all over the planet. And what I really need it to be is blotchy only over specific areas. So that's what I was trying to do by having that mask, that rough mask that we had initially, which is when we do our add this to red, for example, we would end up with stuff that was over the normal value, and that would be our highlands, which we could then impact on. So if we do that, then we can apply this to height, and we can make it apply only to heights that are 0.5 or above, because 0.5 is what we get by default. So once we add to it with our highlands, these are the places that will be affected, in theory. Now the problem is that this is not the sample that we want. This Perlin noise that we have here isn't right. It needs to be a much lower grain. Something is screwy with the nature of this sample, but that's okay, I guess. I don't really need it that badly. But because of the way that this is so soft, we need to have this be a little bit sharper. And to do that, we just drag the minimum up some. And then when we sample it, we have vast areas of dark space. But the edges, aside from at the poles where we've got some weird stretching still, the edges are fairly forgiving. So it's not like they're suddenly crisp edged. Because of that, we should be able to get a good result. Let's go ahead and randomize it. And you can see that this is sort of what I want, but the triperlin cratering is not aggressive enough. So what we're going to need to do is change the noise map, maybe? Or do I just need it to be more aggressive here? So the triperlin noise is not aggressive enough for my needs. I think that's just because the noise map isn't aggressive enough. So let's change it to an aggressive curve and see if we can pull it off. Unfortunately, just due to the softness of the rendering, it's difficult to tell exactly what's happening. If we take a look at the triperlin noise here and just sample it straight up, you can see that it's mostly solid, and maybe that's a mistake. Or maybe I just need a bigger scale. And then if I do that and I take this noise map and I just raise it a little bit, just a little bit. Maybe? Let's try it out. So here you can see some of the modeling I'm going for. See, that's actually really nice. That's exactly what I want it to look like. Now it's only on the highlands. So what we end up with is an area around the modeled place that has this band of height where the Perlin noise doesn't decrease it any more than that. And that just means that our apply to height is screwed up. So basically I'm going to try this until I get until I get that height map to be very close to 0, and then we'll have a nice situation. Now the other thing I can do is I can make this a lot sharper, so this will be our height mask. We'll make this to be red, but right now we aren't channel crushing red, so let's use our channel clear red 0.5. So then what happens is we add our height mask in, and it raises to above 0.5. And then down here what we can do is we can say if it's at 0.5 or higher, you're going to want to apply yourself fairly aggressively. And that's also going to be applied to red. And then we're going to use a channel crusher to print red back onto height. However, when we do that, do we want to add it? Yeah, I guess we do. When we do that, we're going to want to remap it because right now we're based around 0.5, right? If we just add this straight out, we're going to end up creating quite a radical difference in our height. So we're going to use this slope. Oh, no, sorry, this slope, but we're also going to max it out at like 0.5. And here you can see that effect. You almost can't see it just because it is height map only. No biome data yet, but let's go ahead and add in some biome data because what we can do is we can insert biome data here and mask everything that's above 0.5 in the red channel. And that can be our highlands, which can be nice and bright. And then what we'll do is apply that to only things that are above 0.5. And then down here, when we've actually got our craters working, basic biome, we're going to apply this to everything that's below 0.5 and leave 0.5 untouched. There we are. Okay. So this is what, not exactly what I was aiming for, but this is what I expected. So what we've got here is a situation where we are knocking the highlands down a little bit too much. So what we're going to want to do with our triperlin noise field here is change the noise map to be a little bit more forgiving. So we'll just lower it a little bit. That's interesting. So the highlands are extremely bright, vibrant white. And I did that just so I'd be able to see them. But you can see that while we have them working well inside of the noise field, we don't have them working well outside. So the problem isn't what I thought it was. It's not this applied height for our triperlin noise. I mean, it's not the noise map, it's the applied height. So we'll go ahead and fix this noise map back up. And then we're going to go and change the apply to height to be a little bit more strict. Now we are going to end up with a bump. That I'm aiming for a bump. I want a bump. Yeah. So you can sort of see what I'm aiming for here. We're not anywhere near production level for this just yet, but if we change this color to a brighter color, you'll see that it doesn't seem as bad as it looks. What we've got here is a huge amount of pockmarked space. Now the problem is that our highlands are super, super vibrant white. So if we drop that down a little bit, we should have something that's a little bit better. Yeah, that's more like what I'd like to see. So you can see what I am aiming for, right? That is pretty much what I wanted to see. It is a pockmarked section of the moon. And then if we wanted to, so we'll go ahead and say this debris field. Oh, that's not how you spell field. If we wanted to, we could duplicate the debris field and have two of them, at which point we would have a really, really pockmarked planet. This poor planet has been just hammered to oblivion, but that's not what we're going to be doing. We're going to be just using different kinds of debris fields. It should be fun. We're not going to want the same kind of debris field twice. So if I turn back on the first major hits, these should be completely unaffected by the red filtered surface areas. The only problem is they may actually be wiped away rather than unaffected. We should still be able to see them. I'm just not sure whether or not they are actually even showing up. Ah, there's some. So you can see up here it hit on the North Pole, and there's some screw-ups there in terms of scaling. So we solve this problem where textures aren't being applied to the planet necessarily. What I need to do is I need to polish the way that these are properly applied, because right now they are randomly, occasionally applied and often not. Like I've got 2 of these and frequently I don't even see one. In this case, both of them lined up. Pardon me for a moment. Where's my mute button? Hold on. I'm back. Hopefully pressing the mute button isn't like a loud click or anything. That would be a little bit annoying. So this is not too bad. What I also need to do is rough up the surface just in general. Now this foundation is certainly not a foundation. It's just a giant crater impact. But we can add in a basic noise field. And we could try some of these various kinds of noises, but I think that a Perlin noise with a mid-pass is probably going to be just fine as I hiccup straight into the mic after sneezing 800 times. I am the best streamer. And then what we'll do is we'll just subtract that or add that. I'll subtract it, I guess. So that's the scale of it right now. We're going to want it to be substantially... Yeah, that's more like it. Now let's soften it some. If we soften it to one side or the other, we're going to get different results. If we soften it on the low side, we'll get kind of holes in the middle. Whereas if we soften it on the high side, we'll get other methods. Because this is really supposed to be ancient crater impacts that have long been obliterated, we'll soften it so that it has holes in it. And that way it'll look like ancient crater impacts, at least vaguely. And we're also going to want to drag this down because 1 is far too high. I think even that's too high. Oh, don't drag the whole thing down, just the one. There we are. And now if we do that, what we'll end up with is a planet that has a whole bunch of scar marks all over it, like this. Now, I think those are probably a little bit too heavy-handed. So I can try to make it... Well, here's the thing. I'm subtracting them, aren't I? That's the problem. I need to add them. Yeah, that's a little bit more like what I had in mind. So right now, you have to remember that we have this tint by height turned on. When we turn that off, you're not even going to be able to see those. The idea of those craters being there, I think right now the real problem is simply that they're too deep. So we'll just keep lowering the amount, the volume here, until they're not so sharp that they scream. So then what happens is we can take that same foundation and copy this component and then add it in and move it up and reverse it. And that should give us a really choppy feel. Yeah. So that's the sort of mottled field I kind of wanted for the surface of the moon. Now right now we do have a very, very bright albedo. Let's go ahead and darken that because it's a little bit too bright. The question is whether or not that will make our Yeah, our highlands are now too bright. That's fine. We can adjust our highlands down as well. Oh, that's really pink. There we go. So let's take another picture of the moon. The El Butcher says the seam got pretty bad. Yeah, I'm not sure what's up with the seam. It's really noticeable now. I did something wrong when I worked out the way that the seam gets calculated, and it totally ended up botching the backside of the planet. But the thing is that it's botched even without the seam. This pull is what the problem is, and I can't figure out what's going on with that. I don't know what's causing that deformation. It's a pretty simple math. It should work fine, but it doesn't end up working fine at all. We end up getting really, really aggressive deformation over there. If I take a look at the actual height maps and stuff, well, the height map's probably a bad call. How about the albedo? You can see that what happens is at the center line, it's 1 pixel to 1 point of xness. But as it moves up, I have to make each x pixel worth less and less and less, so I have to stretch it. And that's the same on every map you'll ever see of the world, right? At the North Pole, it's really stretched out horizontally. The problem is that it does not appear that this is being properly calculated. There might be something wrong with my math. It looks fine up here, but back here, it ends up being really stretched. It might be because I'm multiplying the x by 2. So right now what I'm doing is when I calculate out noise, I sit here and I constantly multiply this x by 2. If I were to remove the x by 2 from these values here, that's just the Perlin noise field, so it should only affect specific elements. But if I were to run it now, was that the triperlin or the Perlin? Because if that was the triperlin, then this didn't work. Okay, so that's triperlin. That's Perlin. Here's the foundation. Perlin and Perlin. Okay. That's the problem. Multiplying it by 2 apparently makes the stretch really, really bad. All right. Well, let's unmultiply it by 2. The problem is that this means that everything will be stretched horizontally, and we'll have to deal with that. We'll have to figure out the right way to do this. Just clearly multiplying the x by 2 ended up creating ridiculous values at the extremes. So maybe I have to multiply it by 2 before it gets here. Before it gets distorted. So if I go over into the texture proxy here and I get the raw x, so the raw x is between -1 and 1, right? But the problem is that, well, maybe it won't matter. Let's go ahead and try it. Because now our textures are the right width. Okay, so that's still getting skewed. It's clearly not as bad as it was, but look at that. That's obviously more skewed on the back end than the front. Something about this makes this skew worse the further from the midline it gets. The further from the vertical midline it gets. It's fine at the equator, but it quickly gets quite bad. I'm squaring the... so I'm multiplying the x value by the square of the y value. So when I'm at y of 0.5, which would be like here, then I'm multiplying the x value by 0.25. or stretching it out by 4 times as much. But for some reason, it seems to be distorting the backside much, much more heavily than the front side. That's really what I don't understand, and I wish I did. I wish I knew why. So over here, you can see how badly it's stretched, right? It must be that that's not right. It must be that that is not the correct factor. Now, I can change the factor. If I go over here to the texture proxy, I can make this like 1 minus math.abs py, right? Just straight up. But that's not going to actually look very good. So if I were to go back over here to the moon and run it, you get different distortion, and it's still distorting too much to the back. Look at that. Even when I'm not squaring it, it's distorting wrong. So there's clearly something where, yeah, so the squaring is correct. There's something fundamentally wrong with how I am interpreting the way that I'm putting pixels onto the image itself. There's something screwy with that. The UV map is distorting incorrectly. Now I know that the sphere has a very rigidly defined UV map that covers all of the UV space in a grid. So that part's not the problem. The problem must be how this height map is actually being rendered. There must be some way that I can make this render more smoothly, because it stretches really, really bad at the outside edge and then less bad towards the middle. So if I'm defending the x, raw x is just straight up between -1 and 1. Wait, hold on. Raw x is 2 times... Yeah, so that's just between -1 and 1. That's no big deal. And then px is simply raw x with the factor applied. So that's between -1 and 1 still, but it's now stretched, right? Is the problem that it's between -1 and 1 still? Does it have to be different values? Don't really know. I'll think about it some more, but I honestly don't know why it's stretching like that, and I wish I did. All right, so what we have here is a moon-like situation where we've got some basic moon sort of terrain happening. It's not quite as nice as I might hope. Let's take more looks at the moon. What? Okay, so the moon really does have a couple of really, really super big craters. And that really is like the defining characteristic of the moon. It has super big craters. But the thing about these craters is that they are also on the part of the moon that gets hit by craters. So all of this has the issue that it needs to also be applied to the same crater zone, which is not going to work out. I've got this really wicked mirrored seam here too. Sorry, I'm just humming and hawing. I'm trying to figure out how to make this moon look better. And I think that by having better defined areas, it would look better. But the problem is that better defined areas are actually not as easy as they sound. Right now, here, this noise field is the static down here. That's the noise field that we're using. But it might be that I'd be better off with a noise map that is sloped a little bit more aggressively. So here is where it got impacted, and you can't really see anything. Let's try again until we get one that we can see. Here we are. So now you can see that this is a much more aggressive noise field, which just leaves a couple of small height elements. And that's actually much more interesting to me. But let's go ahead and add in a couple more values and details. First off, I really don't like how my textures aren't being properly applied to the surface. And I think it's just a matter of them offsetting incorrectly. Because it needs to be between 0 and 1, but if it's not between 0 and 1, it falls off the edge of the planet, right? So this circle is too much, maybe? Well, it's a little bit better, but it's still, like, not very frequent. Well, the good news is it's really fast if it doesn't work. It's only slow when it works. Maybe I need to divide the whole thing by 2. Because otherwise we're adding 1, and it may be that we want to max out at adding 0.5. No, that's not right. I think that might be as good as we're going to get doing things purely randomly. But there are a couple of things I want to do in addition to just having craters. I can draw more complex shapes that are not simple craters and look a little bit more like actual moon craters. You know, older ones that have blotchy edges. And there are some splotty sort of visuals that aren't really showing up here. The problem is that the moon has very, very different surface elements than mine, because mine shows the height pretty aggressively, and the moon doesn't. For the moon, the shiny parts are the old parts, and the dark parts are the new parts, but they're not substantially higher or lower. They're just different shades. And the reason that is, by the way, is because the moon was hit by a heck of an impact long ago, which covered a large portion of the lunar surface in a dust that all came from the same place at the same speed and created a very even layer, and that shines pretty brightly. And then when that layer gets blasted off by newer impacts, I think this is what happened, then that disrupts the surface and it loses its shiny albedo. But that shiny surface is really covered in lots of small craters over the thousands of years, millions of years, billions of years that have passed. So it's not quite, none of this is quite right. If we look at the foundation, if I were to increase the noise here, the noise scale here, would that give us a slightly better result? Yeah, it's a little bit better. And if we turn off the tint by height, we won't be able to even see those things, will we? Yeah. which is actually fine because we don't want to be able to see them when we turn off the tint by height, because they should all be part of the normal map. This should be 90% normal map. I think this is probably fine for now. We will go ahead and move on with the assumption that this is fine. So we're going to just drop all of these onto the heavy crater. But we need to have a couple more kinds of noise for our moons. So let's go ahead and work on them. First off, we'll just randomize this and see whether that looks decent. Yeah, you know, that doesn't look too bad to me for now. We can polish this up later if we decide to. So what we're going to want to do now is turn off the heavy craters for a second and add in a new kind of field. This is going to be cracks. So for cracks, what we're going to want to do is just put creases into the surface of the planet. So we're going to need to have some basic noise, and we're probably going to want to use tri-Perlin mid-pass. Let's see if we can get the mid-pass even tighter. We're going to go ahead and make that a subtract and just see how that looks. Now I have some things I'm planning to do that are a little bit more interesting, but we'll just see how that looks. So you can see that what that results in is these dark, unforgiving streaks. I think that maybe tri-Perlin is the wrong noise field. Let's try just Perlin. And we'll increase the scale some. Yeah. So what we're going to do here is we're going to make it equatorial. And to do that, we're going to want a channel clearer. We'll go ahead and smash the red channel down to 0, I guess. 1 is probably a more useful to us. And then what we're going to do is add in a basic noise for our polar Perlin, where we subtract out the inverse of our polar Perlin. Is that really what we want to do? That'll give us very low values in the middle area, which isn't actually what we want, is it? Let's go ahead and smash this down to 0 rather than 1, and then we'll change this to add, and we'll make this a very small add, like just 0.15 or 2 or something like that. And then we'll just take a look at this sample. I think we want it to be a little bit less. So sample. Oh, well, that's actually kind of fascinating. I'm not sure how that worked. I think it's just noise damage. Yeah, I don't really know what happened there, but what we'll do here is this is going to be on red. This is going to be on red, and what we're going to do here is we're only going to apply it to heights that aren't 0. Oh, not like that. Like that. Not like that. There we are. But we'll apply it full force to anything that isn't 0. And that will make this into an add rather than a subtract. And then at the end, we'll use a channel crusher to crush the red channel back into height using a subtract function. And that should be maybe a volume of 1 is fine there. But there's one more thing we want to do. We want to create a new basic biome here. That's not a basic biome, that's a basic noise. Remove that. Basic biome here. And this is going to be our glow, because these are going to be smashed so hard that they're still glowing. So So we're going to go ahead and apply emission. Now we don't have emission working yet, but this will be quite a visible set of features here. And we're only going to be applying this to values that are high, like this. There we are. So what we're trying to do is get some glow-in-the-dark features, but our Perlin noise isn't quite, our triperlin noise isn't quite picky enough. So let's go ahead and make it a little bit, sorry, our polarperlin isn't quite picky enough. Let's go ahead and make it a little bit pickier. And then maybe increase the scale. Abaz says, fire. Yep. So one of the issues I've got here is that these cracks are super, super sharp. And so they look a little bit bad. I can certainly, we're really looking at it from this distance. I'm looking at it really close up just because I'm trying to study it. But from this distance, these are the areas where we would see the cracks, right? But it might be best if the cracks weren't quite so sharp, because then what I could do is add in some darkened, blackened edges. And that'll look pretty good, I think. So what we're going to need to do is, these are the ones that are glowing. Yep, that's them. We're going to go ahead and sharpen or soften the edges here. But we're going to want to soften the edges to a point rather than to a curve, right? So we'll go here, we'll break this in half, and then we'll just do it to a sharp point. Nope, wrong button. Come on. Now that'll give us a little bit of some edge work, but we don't have the edge work actually filling in properly. So what we'll do is we'll have this basic biome here only apply to the deepest areas, and then what we'll do is we will apply a much less silly, a much less emissive and darker element to the edges, which we'll do just by using the red channel and picking up a height where we're only going to be applying them to things that are like between 0.7 and 0.9. All right, so that second application isn't good enough. We'll go ahead and make it 0.6 to 1, with just relying on the fact that it's not applied at a full force to make that one work out. Maybe we need to soften the cracks even further. So here are the cracks that we've created, and it's clear that these are not soft enough, so we'll just go ahead and pull them out a little further and raise them up a little higher. Well, now our dark center points are a little too dark. Let's go ahead and swap these two. And that way we'll be able to have this just get applied all the way to maximum here. And then what we can do is actually, and then we can do is apply this basic biome to only the tightest little piece at the very end there. That didn't change jack shit. Oh, yeah, broken. Correct. Ah, that's more like what I intended to see. Although I think we may have ended up tightening it up too much. No, I just aren't applying it. I can see the gray values where the rock should be, and it's not getting applied. So, there we go. So that's obviously too much. A little bit of this and a little bit of that. So what did I screw up to do that? Did I... What? What did I just change a second ago? So I changed the way that it was filling in here, right? Yeah, okay, that's what I did. I just hit Control Z a bunch because I lost track of what I was doing. Wow, that's really sensitive. It might also be that I had accidentally left it floating above 0. We'll find out now-ish. This is interesting. Am I not attached to red? No, I'm attached to red. Wait. I modified the wrong thing again, didn't I? I modified the debris field. Okay, that was the problem. I was selecting the wrong thing because I'm an idiot. So the cracks are what I'm trying to modify, not the debris field, you big idiot. God damn. The biggest problem is, yeah, people are dumb, including you. Everybody's dumb. All right. This is what I was expecting to see. So obviously this isn't right, and what we're going to do is not select the debris field, because it's not a goddamn debris field. We're going to select the cracks and modify this until it feels right. And this down here, we're very, very choosy at the minute. We're going to go ahead and make it a little less choosy, and then run this. Ah, more like it. So it's still not perfect. Let's go ahead and make it even choosier. That's the debris field, you idiot. So if we pull this in and pull this in, we can delete these 2 points and make these quite sharp. Nope. That's what I wanted to see. All right, so now we have some areas that feel a little bit more like what I wanted to see. And the glow-in-the-dark elements will definitely make this a lot better. Now, if we look at the seam, we're going to see that that doesn't work out very well. I'm not really sure. I know what's causing this. That's actually my doing, which I can fix. But the stretching is still really obnoxious. Abbaz says that that's a hot crack. Yep, and if I increase the resolution to what we'll likely use for the final planets, you should be able to see them more clearly. Yeah, see? So you'd be able to see it much more clearly and interestingly at this distance. Now what I did is I used a Perlin mid-pass. I could also have used a tri-Perlin mid-pass, which would have created a lot of forky bits. It might be worth examining that. So if we switch from using Perlin to tri-Perlin, oh, I left it at high res. So this is not the end result. We're going to end up needing to move the exact point of the of this here, because the tri-Perlin noise field is not balanced the same as every other noise field. So if we move it up to here, we'll probably get a better result. No? You know what? I bet it's just not updating properly. I bet it'll work fine if I actually hit run. Yeah. So the tripurlin field has different shapes to it that end up looking much more interesting. Now we're going to want to bring that tripurlin scale down a little bit. It's a little bit too cluttered. Yeah, that's better. And that gives us a more organic set of shapes. Rather than the soft looping shapes that we had before, we're now going to get some butt shapes. And some fun, chaotic elements like these circles. And that gives us something that looks neat. Don't you agree? I think it looks pretty neat. So basically what we're trying to do here is we're just trying to create some moon elements. And just for now, I think that'll do. We'll go ahead and save these elements as components. And then later on we can add more if we need more. So this will be moons. Obviously, there are a lot of other things moons can have. Abaz says, what if you make the scale larger? It looks more like tectonic plates. That's what I'm going to end up using for the hot planets. For moons, I don't really want them to feel tectonic. But we haven't gotten quite that far yet, so, you know. So I think foundation is going to be the same regardless of what we do, but we can have the others change a little bit based on a randomizer. So we're going to go ahead and do debris fields. And then what we'll have is a chooser, a randomizer, which we will drop in a set of possibilities. So we'll go ahead and drop in the debris field and the heavy craters here. And then we'll duplicate this, and then what we'll do is we'll have this be the heavy craters and the cracks. And we'll call this new debris. And we'll delete these. And that means that we'll get 3 elements, and it could be 2 sets of heavy craters. So you can see that we get a variety of results, which makes each planet hopefully look a little bit more unique. And I should be able to make them feel more and more unique by just changing some of these values, adding more of these elements. It's not too difficult. So it should be fun. Should be fun to create if I want to. But I think I'm going to move on to another category of planet. Because right now what I've got is moons and Earth-likes. And what we really want to have is a couple more, because there's not just moons and Earth-likes. We've also got the small hot planets. So that's what we're going to work on next, are the hot planets. Now, the difference between the hot planet and the others is actually pretty sparse in terms of the basic idea, because moons and hot planets share a lot of the same geography. Abaz says, this is such a cool generator script. Yeah, the problem with it is that I made it a little too powerful while sacrificing some quickness in terms of my ability to create crap. I didn't really have any option, though, because I didn't know what I wanted to create when I started. So I needed to allow all of these possibilities so that I could, you know, actually play around with it. But playing around with it takes time, and I spent the whole weekend just creating planets. Anyway, what we're going to want to do is a very similar thing to what we just did. We're going to want to have a channel clearer, which clears to anything. 0 is fine. And then we're going to want to add in some, come on. We're going to want to add in some Perlin noise of a very, very low scale. That's not the Perlin noise, and you know it. That's more like it. And then we're going to want to have a noise map which is a little bit picky. And that way we can have a mask, and we can apply something to only these masks. But in the case of a hot world, we need to do another thing, and that is we need to crush this channel back down to 0 at the poles, because these don't have the pole elements. So yeah, something like that'll work fine. And then that will subtract off of red. And then we will, everywhere that red is now higher than 0 is a place that might be baked. So we're going to go ahead and add in a basic biome for that. And we'll just apply this to everything that's higher than 0. And the uneven application should allow it to feel a little bit unusual. We're going to also do some more work on this. We're going to scribble on it and do some other stuff. But just for starters. Well, let's go ahead and make it burned black by default. And we're going to want to actually bake that channel back into the main height. So what we're ending up with is it's very, very orange. And the reason for that is because this basic biome is being applied at 0, which is a little bit too much. And it's a little bit better, but not better enough. Let's go ahead and make this a little bit more restrictive on the purlin here. It's interesting how aggressively this is working. I didn't think it was going to be this hot. It's interesting. Okay, that's better. So now we've got this planet that has this dark ashen color. And what we would like is for it to glow red on these high points, which is not happening right now. I can't seem to find the dividing line between these heights, and I don't know why that would be, because there shouldn't be a dividing line. It should be 0 or something. So I'm not sure why it is. Oh, do I have it set to use height? I do. That was the problem. Okay. So now what I need to do is fix that so that it's back to where it was in the beginning, which is what I thought it had to be, and I was right. I just need to make sure I wasn't being stupid. There we go. So now we have some areas that get baked, and we set that up to be this kind of orangey color. I think it would be better if it was darker, like down here. And we'll set that up with a small amount of emission. And then what we're going to do is we're going to scribble all over the red channel. So let's use just a basic noise. Going to add height. Some tripurlin with a mid pass will look good. And add that to the red channel. Sample that. Can't see it. There we are. Yeah, that's a little bit better. Maybe even more. All right. So what we're going to do is we're going to add that to the red channel. Or the problem is the red channel might already be at 1, and in which case this won't help any. But we'll see. We'll see. It might be okay. And then what we're going to do is we're going to make that friggin' glow. So it's going to glow an orange. We can fix the glow color to whatever we would like later. And we're only going to apply it. We're not even going to change the final height. We're only going to apply it to places that are super, super high, like this. Did I pick red? I did. Good. So you can see that what we end up with is a series of glowing elements, but these go all the way up to the other parts of the planet. So what we actually need to do for this noise field is only apply it to places that are already above 0. Oh, that didn't work out. Oh, hold on. That's just the biome. So, this one. Hot crack. I don't seem to have what I thought I would have, and that is to say anything. For some reason, the whole planet has gone dark. I must have screwed something up. So we add in some Perlin noise. Okay, so we don't have any good Perlin noise on this planet right now, but we should have some over here. And then we subtract some polar Perlin red. That should be fine. And then we, now that's setting it back down. So crush to height. So we've got like a tiny little patch here, but then we don't scribble on it very well. So these hot cracks are obviously not getting applied properly. Or we need to change the noise map or something. So what does it look like? Yeah, so those should be applied fine. We are applying to red. We are applying to red. This should work. All I can think of is that for some reason this didn't work out. So we're going to go ahead and max it out. Yeah, and then what we can always do is go back in here and tell it to be shorter. Oh, no, not that. God damn it. This. So when I bring it down to 0.5, it then immediately stops working, which implies that the noise we're getting out of this stuff is pretty low. It's not going up anywhere near to 1. So we're going to go ahead and create some bigger, more notable noise fields here. There we go. That's what I wanted to see. Thank you. All right, now we're getting somewhere. So that should look pretty damn good, don't you think? I think that looks friggin' marvelous. I may be biased. So we're going to go ahead and make this planet have a default that is a redder hue, because it's a little bit not red enough. Is that too purple? That's too purple. I guess it's really an orange, and that's what our default isn't. It's not orange enough. That's a little bit better. Okay. So this is what I expect from a hot planet. So let's go ahead and look up pictures of Mercury. So what we're going to do is do a Google search for Mercury. And I'm taking some serious liberties, obviously, because Mercury doesn't really glow like this, at least not on the side of the planet we can see. But I just want to get a feeling for the topology, because this is basically flat. There's no actual topology to this. But on Mercury, what you get, on any kind of hot planet, what you get are these streaky lines like rivers flowing across the whole planet. This is very similar to that. In fact, it's probably the same thing, so maybe that's fine. And what I need to do is, this will be big patches, and then what we'll do is we'll create a duplicate of that, and then hide this, and then the duplicate will be small patches. River patches. And the river patches will, instead of taking this purlin noise as it is, we'll do a mid pass. Yeah, a mid pass like this. And if we just take a look at what that noise will look like. So if we want to get this to be more like rivers, I think we're going to need to increase the scale just a little bit, maybe? No, then we'll have to soften it some more. Yeah, that's maybe a little bit better. Should I reduce this and then unsoften it? Yeah, okay. Let's reduce it and then unsoften it. So we pull this forward, and pull this backwards. Rivers, good. So now if we run this, we should end up with rivers rather than big patches. Now you can see that the rivers have some spots that are actually maxed out. That's fine. But it doesn't look very good with what we're working with at the moment. So we're just going to pull our purlin noise down a little bit so that doesn't happen. There we go. And you can see that what we get is much more rivery. So what we're going to want to do here is the hot noise that we create down here, we're going to want to reduce the scale. Because it was a little bit too heavy. So once we've reduced the scale, yeah, that's more like it. So you can see that what we get is a much more rivery sort of feel out of that. But this is river patches like this. We're also going to want to have crack patches. Now the crack patches are going to be the same basic idea, except that we're going to use two distinct sets of noise generation. So to do that, we're going to basically duplicate this noise field. So we'll drop this in, copy all of that stuff and paste it in as values. And then that will mean we'll have two sets of these, but we'll increase the scale. And then what we'll do is at the end, we're going to go ahead and crush it down a little bit. So we use another basic noise here before we get to the polar purlin. We'll use flat, subtract from red, and we will just crush it down to a little bit, not too much, just so that it's not at 1. So you can see we've got some creases, but they're not big enough. So what we're going to want to do is change that crush, flatten to prevent maxes. Change this crush just a little bit so that it's not quite as aggressive. It's a little bit more like what I want, but I think we're going to want to change the purlin noise that we've got to be even more strict. There we are. That's more like what I had in mind. Now this is more like element of decoration, but it should work. What we're going to do is we're actually going to delete the polar purlin element. And the reason for that is because these cracks can certainly run all the way up to the North and South Pole, but you can see that what we've got now is this unfettered wide band. And to fix that, what we're going to want to do is break this. No, not flatten, break. And just change the slope. We'll do the same here. And I may have to re-widen those, we'll see shortly here. All right, so I have to re-widen them. It's not a big deal. I just grab this and move it. And these, I need to adjust them. Ditto here. Well, that didn't actually work at all. What happens if we remove this flattening? Because I don't think we need it. And then what we can do is see how that looks. So now we get these streaks along the course of the river, which is actually kind of what I want. So let's take this hot cracks element and make it sharp. Ah, that's more like what I was expecting to see. However, our cracks are a little bit too forgiving, so let's just pull these up into the 9-band only. There. So we've created a whole bunch of patches, but what we haven't done is actually roughed up the surface of the planet at all. So we ended up with this situation where our planet is like a cue ball. But obviously that doesn't happen. Even on places like Mercury or Venus where there is some amount of activity to hide this stuff, we don't end up with just cue ball planet. So we're going to have a couple of different rough up the surface functions. I'll call this surfacing. And the most basic thing we can do is simply add some random crappy choppy noise. Add or subtract, really, either one works. So we'll go ahead and set this up to be some kind of mid-pass, I guess. It doesn't really matter. So that will end up creating some really interesting crisp shapes. We can soften the shapes a little bit more. They're a little too crisp. Whoa! Now they're super crisp because it broke. Yeah. Something wrong with the way that I'm sampling those, but whatever. So let's go ahead and hide this so we can just take a look at the surface that we're working on. So this is how it looks right now. What we're doing is we're subtracting out a huge chunk of the surface, and we're only leaving specific patches. This is very similar to us adding in specific patches. There's no functional difference. You know, what we'll do is we'll just take the surface and we will copy and paste here and make this an add with a different set of scales. And now we have a surface that is quite different. Now what we're going to need to do is not have these at 1. 1 is far too aggressive. So we'll just lower these down to less than 0.5. That way we won't have any maxed out heights or anything. Much better. So now we've got a nice mottled surface. And if we turn on that big patches again, what we'll end up with is a wonderful mottled surface with massive cracks. Now we're also going to want to have the ability to punch in stark holes. These holes can be created by meteor impacts or by volcanic explosions. But any way you look at it, they're basically craters like you'd get from meteors. So that's what we're going to do now. We're going to go ahead and put those at the end. Hot hole. And the difference between them and a meteor in terms of how we're doing them is that we're not going to try to create a tri-Perlin mess. We're going to use just standard Perlin. And then we're just going to apply it to apply it to noise map with a very strict noise map like this, right? But it's not a crater. It's just a weird looking hole. So we're actually going to make it sort of shape the opposite of a crater. And that should work. Now we also need to add in some biome elements for this. The problem is that right now we're going against height, and that means that this isn't going to work out. So we're going to use a channel clearer, and we're going to clear out the red channel again. And we're going to clear it to 0 is fine. And then when we do this, instead of subtracting, we're going to add them. And we're going to have the height of these actually get subtracted from the height of the rest later on. But we're obviously doing this on the red channel. And then what we're going to want to do is put in some biome stuff. So we're going to have this really, really dark, ashy element for what we're seeing inside of these. And then we're going to have a white hot glow. And the white hot glow will only be applied to the very deepest portions. And then we're going to apply all of that back to the height, because right now it's still in the red channel. So we'll take the red channel and subtract it from the height. Boom. So we're looking for the hot holes that we've created, because I don't really know whether or not they exist. Oh, so there should be one down here. Okay. Oh, it's barely visible at all. Okay. So I think that it might just be that our hot holes don't have that hot base that we expected them to have. So what we're going to do is we're going to take this and we're going to just adjust it so that it is more like that. That way we'll be adding a massive amount, and then here we'll go ahead and drag this back and make it a little bit more forgiving. Maybe I do want to use triperlin, because this is not giving me enough patches. So we're definitely getting some. This is obviously one of them, but if we take a look, they're not red. Yeah, so they're not really getting this. Maybe it's because the alpha's too low? That doesn't make any sense. This is not really working for some reason, so we're going to just keep making it more and more forgiving until it works. There we go. So that's going to be like a glowing hole. I guess it's not really red enough, it's too yellow. That's going to be a glowing hole in the planet, and those should look fun. This one's a little too big, but that's okay. All right, so let's go ahead and solidify this into a set of elements. Create folder hot planets. And we will just drop some of these in. So we got big patches, we got river patches, crack patches, and hot holes. There are other things we could do. Like, for example, we could toss in some of these moon things. Like these cracks. Let's see whether or not the cracks look decent on the hot planet. Well, having all of that on is obviously not working out for us. I can't even see them. Well, it shouldn't matter. We'll just delete all these now. And what we're going to need to do is create some heat elements. And these are going to be randomly chosen between some of the heat elements that we've created. So big patches, and river patches or crack patches? River patches. And then we'll go ahead and create another one of these for surface heat. And we'll go ahead and make these between crack patches, hot holes, and river patches. And then we can just add in a detail here. So we'll duplicate this and call it detail. And these are going to be hot hole, or I don't know, we'll pick some stuff from the moon just to have some fun with it, right? I don't know whether those will actually work because I didn't balance them for this planet. Still, now if we hit randomize, we should get some interesting results. Yep, this looks okay for hot planets. So the real problem with me saving all of these prefabs as they are is simply that we are actually reusing the same height map, albedo, and metallicity between all of them. We're going to address that at a later time. We're going to be using a texture pool. But for now, we can leave it like that. But we can't leave it with these being textures that exist, because otherwise they will overwrite each other, and that will be dumb. So for now, we're going to go ahead and clear them out. None, none, and none. Good. Elbow says, I always thought those noise fields were pretty good for lava planets, and now I can see them. Pretty good. The variations are pretty amazing, surprisingly not alike. Yep, that's the idea. If they were all alike, that would be annoying. Got the Earth-like and the Moon-like. So let's go ahead and just create a little solar area for our planets. We'll go ahead and shrink this guy down, and we'll just create this guy as a moon, a hot moon. And this moon-like element, we can duplicate it and create a second moon over here, right? Sounds good to me. And what we'll do is we'll just adjust these to use more detailed maps because they're bigger. And then we'll take this camera and we'll move it until it can see all of the planets. I think we'll be better off mostly rotating it. There we are. So what we're going to do is we are going to just trigger these planets one by one. Did I hit randomize or run? I think I hit run when I randomize. The higher detail level takes a while. I think actually that the Earth-like planets are the most expensive in terms of computation. But yeah, there we go. Unfortunately, our moons look a little too similar. We're going to expect that from time to time, but for the sample, let's go ahead and recalculate that. And I'll just go ahead and post some screenshots, and then we'll get on to making emissions work. I don't know if I can make everything work, but emissions I can certainly make work. And then I'll look into making a normal map. Planetary variety. ProcGen. And then we'll just recalculate all of them. Can I recalculate all of them at once? Let's find out. Yep, I think I can, because it's taken a long time. Yeah, well, I don't like any of those results. I think I might have to fix the moon a little bit. That was the one I was most uncomfortable with originally, wasn't it? The problem with moons is that they're inherently boring. That's kind of the point. But I need to make it so that they don't feel boring. And a big part of that would be to properly get the lunar craters looking good. And that would just require redrawing it with that in mind, which I'll do. I just haven't gotten around to it yet. This will be the last one I take a photo of, and then I'll get on to making that emission work. Oh, it's ugly. Okay, one more. Well, that's also ugly, but one more. It's okay if they're ugly during gameplay, because you can just go somewhere else. But if they're ugly while I'm trying to take screenshots, that's no good. I'm really curious about this seam. It's really quite unusual, quite a very distinctive seam. Not good enough, I suppose. Elbow says you don't have to randomize every planet, right? I can. I mean, I don't have to randomize every planet while I'm taking screenshots. That's true. But there's no reason not to, I suppose. I'm not in a terrible hurry. But what we're going to do now is go ahead and create that emissive texture. So to do that, we're going to close everything other than this. And basic noise, which apparently changed. I must have hit space. That's all I did? Okay, whatever. So over here in the planet, we're going to need to have a new texture. And that new texture is going to be for the emission. So down here, when we're creating stuff, we're also going to have to create an emission. Now, you might be thinking that the emission map needs to have a pixel list. It does not. We'll just create and then discard a pixel list as we need it, rather than storing it, because there's not going to be any need to pass that information over into our various processing units. We'll just run through it once. In fact, what we can do is we can reuse one of the other elements if we'd like, but that would be a little bit risky, so we're not going to. Metallicity gets set up using the metallicity pixels, and then albedo and height map both get set up. We can probably reuse the height map. The only problem is that when we're processing it in the real game world, we're actually going to go through the height map step by step, each frame, so we can't overwrite it. We'll just create a new one, no biggie. So what we're going to do is down here in the processing map, apply emissions. So we'll just go ahead and say color 32, emission pixels. That's an array. Equals new, color 32, and then we'll just pick the metallicity pixels, because these are what we're going to be copying from. For int a equals 0, a is less than metallicity pixels dot length, a plus plus. And then what we're going to do is we're going to copy over the color from albedo into our emipixels based on the blue channel of our metallicity pixels. So float emission equals metallicity pixels. Let's go ahead and switch over to using underscores at this point because it's a little bit faster. Metallicity pixels a dot b. That's going to be a float. Did I spell these wrong? Metallicy pixels? Have I been spelling it metallicy pixels the whole time? I think I have been. It's okay. So this is a float value. So it's metallic pixels when it's public and metallicity pixels when it's not. So obviously we're going to want to fix that because that's dumb. We'll just refactor this to be metallicity. There we are. So if emission is less than or equal to 0, then continue. Otherwise, we're going to want to copy over the value of the color into our new pixels. So we just go ahead and say color 32 ME color. So ME color equals albedo pixels A. And then we're going to go ahead and run between that and black. I think we've got black. Yeah, we got black. So, except for we need to change black. So when we get here, what we're going to want to do is lerp between color32.lerp between black and albedo pixels A based on our emission. And then what we're going to do is say that mecolor.a equals emission. Actually, I'm not sure which way this works. If it only cares about the alpha, then we don't have to do this. And I think it does only care about the alpha. Let's find out. And otherwise, we will do a float to b. But unfortunately, that doesn't exist on the planets. It only exists on the other script. So we're going to open up a texture proxy, grab that float to b, and drop it into planet as well, just so we've got it in both places. I don't feel like, well, you know what? I can just make it static. So then we can just say equals texture proxy dot float to b, and then pass it in that emission level. Or we can just say that mecolor A equals metallicity pixels A dot B. Pretty basic, right? And then what we'll do is we'll just assign that to the ME pixels. And at the end, we'll say that we are going to put that into a new texture. However, we only want to do that if we have any sort of pixel that has any emission. Bool anything emitting equals false. And then down here, we'll go ahead and say anything emitting equals true. And then down here, we'll say if anything emitting, then what we're going to want to do is actually set up this whole situation. So we'll just do emission dot set pixel 32 ME pixels, and then we'll do emission dot apply, and then we'll want to create the property block. Now, otherwise, we're going to want to note that the property block has an emission or not. Include emission equals false. So if we are including emission, if include emission, then mpb.setTexture emission map, probably not. We'll have to look it up in a second. Emission. So let's go take a look at our planet shader. We'll go ahead and hit edit and look for emissions. Glossiness, metallics, specular highlights, occlusion, emission map. Yeah, I got it right. Hurrah! I'm pretty good, right? So now we've got some emissions happening, in theory. Shall we see whether or not this works? So if we select our hot planet, that's the one that's definitely going to have emissions. We'll go ahead and run this. And I don't see any emissions. So let's look at the dark side. Are you glowing back here in the dark? Yeah, I guess those are technically emitting. It's just that I really am not very impressed by it. If I take the directional light and shut it off, you know what the real problem is that our lighting is terrible. So let's open up our lighting window. And we're going to go ahead and turn this down to a black. And that should work. Yeah. Right? Yeah. Right? There's no other magical darkness I need to put in, right? There's no longer a, is this it? No, that's fine. See, the problem is this is still not black, like by any means. So there's something wrong with the way that the sunlight is being calculated because we're not getting any darkness. See how it's not black? It's not black, and it needs to be black. There we are. Skybox is screwing it up. All right, so there we have it as a very, very black scene, which is fine. But what we want to see is whether or not that black scene is properly illuminated by the glowing red elements. And it's clearly not. You can see right there. For some reason, in scene view, we're not getting the right lighting. I guess so that you can see what's going on. But even with this view, you can clearly see that we're missing quite a lot of what we're going to want to have glow. If you take a look, that goes into being a whole river of red, and it's clearly not. So if we then select this planet and take a look at the emission map, albedo, height, occlusion, detail, emission. Interesting. Okay. So do we need to turn on emission? I think that that's a separate value, isn't it? Let's take a look here. Edit. Emission color, emission map. There's no emission bool? Well, if I can't change the emission bool, then I've got to just turn the emission on for all of it. Well, let's see whether or not this works. If we run this planet one more time, we should see it pop up over here, right? No. Okay, is it? Oh, I need to recalculate the mesh here. Hold on. Now it's still not emitting, but at least now we do have, in fact, an emission color. If we change this to white, then you can see that that's technically what the emission is saying. Obviously, we need to rebalance some of that emissive value because that's pretty emissive. But the problem is that when we're not emissive, what we would like is an emission color of black. So what we're going to do is here, we're going to say that if we're not emissioning, we're going to do mpb.setColor, emission color, comma, new color 32, 0, 0, 0, 0. It was emission color, right? Let's take a look. Yeah, so with that in mind, if we were to recalculate all of these, the moons might barf. I just realized that because the moons need to have their emission recalculated as well. Yeah. So let's go ahead and tell the moons and the planet, tell everybody to restart their height maps and stuff. That way we won't have this problem where we have it barfing and coming out as pure white. All right, so now we do have it glowing properly, and as you can see, there is some stuff going on with these planets as well, where they also glow. What we've got is some problems over here on the hot planet, where I have ended up creating some problems by having too much of the hot planet glow. So what we're going to do is we're just going to go into the hot planet's elements, and we're going to make it so that the glowing isn't as universal as I made it out to be. So that should work. Alboechi says you should probably blur the emission map. Yeah, let me go ahead and just see how this works first. And then we will think about what we want to do in terms of blurring. So, to be honest, I think that looks pretty good. I'm not sure it needs to be blurred. The problem is that the moons have a very, very low resolution, and the result is that they are annoying. But the emission maps problem might simply be that it is too flat. And it might be better if I offset the emissions alpha by a certain amount. So if I were to go over here into creating our emissions, I can see this emission is less than or equal to 0, continue. What I can do is I can adjust this emission. So emission plus equals random.value minus 0.5f. And then we'll just repeat this process, right? Oh, except for that actually doesn't work because we're not modifying the emission. We're taking this b here. So byte bemission equals that. If bemission is greater than 150, then bemission minus equals mathf dot ceal to int random dot range. Actually, I can just ask it for an integer range. Random dot range. That's not how you spell random. And we will pass it integer values of 1 to 20. Else bemission plus equals. Now, this has the advantage of when we're recalculating it, it will change every round. Not sure if that's good or bad, but this will just be bemission. So if we recalculate this planet now, ooh, cannot cast int into byte. Really? That's annoying. Let's go ahead and make this an int. And then down here we can just cast it to a byte. I can't actually tell. Yeah, it's finished. It just doesn't show up very well. I don't see any difference in the amount of bemissions it's getting. Let's go ahead and up this to 100 just to see. You know what? I don't think that the alpha counts. I think that it is running purely on color rather than on any kind of alpha. Okay, well, I can work with that. I can work with that. So what we're going to do is, instead of using bemission, we're going to go ahead and change the emission value. So emission plus equals random.value minus 0.5f. Anything emitting equals true, and we will go ahead and lerp between the colors, and then we will try it one more time. Oh, I didn't let it recalculate? No, it should be recalculated. So if we look at the colors here, they're very, very strong. Is the emission map not updating properly? Let's go ahead and... Oh, I just hit randomize, which wasn't very bright. So you can see that the emission map is happening, but we're not getting the variation that we should be getting. In theory, this should be varying between 0.5 and like 1.5, even if the emission is maxed out. But instead what we're getting is this very, very flat and unchanging edge. I'm not sure why. That's really strange. Look at this. There's no difference. What the heck's going on? How come the emission map... Am I not applying the emission map? Am I applying the color map or something? Emipixels. We created the new emipixels. We applied it to the emission map. We send it up here into our height map applier, our material property block applier. It applies it to the emission map. So this is definitely the emission map. And if we take a look at the hot planet's other values, the albedo is definitely different from the emission map. So we're not duplicating a map. But for some reason, we're not getting the values that we should be getting out of this map. They should be like rough and pixely, and every one of these points should have a different value. So why isn't that happening? And maybe the lerping is busted? So it's definitely triggering the emission calculation. But this randomization isn't happening. And I can tell it's not happening because I didn't see any change. And if there was any randomness, I would see a change. Just looking at this, there would be something different because it's supposed to randomly vary, and there's just no difference here. So clearly, it's not randomly varying, even though I tell it to. The only question is why? What's up with it? All I can think of is that this emission variable isn't properly working. So if I wanted this emission variable to properly get tested, I'd want to radically lower our size just so that we can do this without having 100,000 echoes. And then what we'll do is use debug.log emission. And then here we'll collapse it, because otherwise we will end up with a lot of extras, and we'll run it. So you can see that these emission values are not between 0 and 1. See, the problem is that I'm an idiot. God damn it. Yeah, I can raise them back up. I was multiplying by 255 instead of dividing by 255. There we are. That's more like what I expected to see. All right. And so that is a little bit less even, and it should be a little bit better. Now, the problem we've got at the exact moment that we're looking at this right now is that we are not emitting into a range that is causing us any sort of fun side effects with our camera. So we're going to add in an adjustment layer to the camera. I've forgotten what they're called. What are they called? Light map parameters? No, that's not them. Yeah, the bloom effects and stuff. There's a new name for them, and I've forgotten them, and they're not here. It's not a light map parameter, is it? That doesn't make any sense. No, that's not it. Crap, I've forgotten what they're called. The new post-processing stack. But there's no post-processing object here. Well, let's go ahead and add one here. Post. Huh. Is it like something I've got to import? It might be. Assets, import package. Effects. I've forgotten how to do this. I mean, I can add in the old post-processing effects, but what I'm basically going to do is add in some bloom and then darken the sky and then add in a light ramp after the bloom. But yeah, Google Foo would be nice. I don't want to go around Googling things on camera. I think what it was is a package that you're supposed to download. I probably have it right here in the asset store, depending on whether or not Unity knows what it's doing. It does not. Unity has decided that it is broken. Great! So I can safely say that Unity, their authentication system, is deeply crap. It won't even let me access the stuff on my machine unless it remembers that I'm logged in, and it barfs like this. Give me a fucking break. What a pain in the ass. Yeah, so what I need is, I know how to do it once I've got the post-processing stack. I just don't know where to get the post-processing stack. And they don't tell me on that page. Post-processing stack. You can download it from the asset store. Thanks! Fuck you! Oh my god, that's so dumb. Okay, so I've probably got it right here. Dynamic decals, Obi rope, mesh baker, simplify editor. Nope, it's not here. I guess we'll have to manually go over to the store and look for it. Post-processing. That's not how you spell it. Post-processing stack. By Unity. That's the one. Yeah, fuck you. All right, import all that crap. Well, that was annoying. It's interesting that it's no longer part of the default install. I wonder whether they'll fold that back in later, because most games that use 3D graphics use some kind of post-processing. And it's really strange that it's a separate package that you have to download from a buggy store. Hey, look, it's barfing more random red lines because it's not very smart. So let's go ahead and create that post-processing stack. There it is. Camera. And then we're going to go over here to the camera and create the actual stack. Post-processing behavior. Drop that profile into this behavior, and then we'll edit this profile to include all of the things I want to include. We don't need fog. We could actually use anti-aliasing. We'll go ahead and do that later, though. Screen space reflection is not something we're going to need, I don't think. Depth of field would be fun. That might actually be pretty cool, but we're just working on eye adaptation and bloom right now, and we're actually going to want them in the opposite order. Can I not put them in the opposite order? That's really obnoxious. Abaz says that I've taught his daughter all kinds of bad words. Yeah, I'm not sure that if your daughter I'm not very G rated. I'm a programmer. I'm not aware of very many programmers that are G rated. So if you are trying to get your daughter to not swear, I might be the wrong person to watch. Okay, so what I would like to do is turn down the main camera. Nope, turn on the main light, I mean. Oh, excuse me. And if I darken it like this, then anything that's light can be blown out into a large bloom. So we'll turn this off, and then we'll take this bloom, and we're going to go ahead and adjust it here. Now, the problem is that what I really need to do is have this at eye adaptation. I guess it... See, the problem is I don't want the eye adaptation to end up happening after the bloom. I want the bloom to happen first. But I don't know of any way to reorder these stacks. Well, I can always use color grading. It's the same basic idea. So we're going to go ahead and just adjust the color grading until it feels bright. Let's go ahead and try it. Woo! Blow it up. Unfortunately, it looks like the bloom is going to happen here as well. I guess that's okay. I can adjust the bloom again. Boom, 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 jump, 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 jump. And then here in the bloom, we can just adjust this until it's only the glowing parts that are blown out. There we are. And hopefully that'll look pretty good. Wow, it looks terrible here in the scene view. Wow. Well, we can turn it on and off, I suppose. But the problem is that the scene view has lighting turned on, and it looks like it is going berserk. Even when I turn lighting off, it still leaves the post-processing stack on. And there's no way to turn it off. Maybe this isn't why it's included, because it's not quite ready yet. That's frigging hilarious. So the idea here is that we'll be able to see the blown out parts of these planets with bloom effects, so they really look like they're glowing, and that's going to apply to cities and things as well. But we definitely need to work a little bit more on balancing it, because right now it's still not great. So let's go ahead and keep adjusting things until it looks like I want it to look. If we make this 0.25, it should be easy for us to work out the math that we're going to need. I could just go ahead and let it use color adaptation or eye adaptation, but I think the eye adaptation is nowhere strong enough. But the thing is, it's so the problem isn't that it's nowhere strong enough. The problem is that it's set to progressive. It's really not very, very strong here. Well, if I do the eye adaptation, the problem is it happens before the bloom, because it's not properly it can be graded right out of the. Wah! So if we do the filmic channel grading, then it's possible to do some pretty interesting stuff, including some post-exposure adaptation, which is probably exactly what we need. So we may just use this. 6.5 stops. That's pretty dark. And then if we wanted to, we could do things like adjust the temperature and stuff, but I don't think we're going to need to do that right now. We could adjust the saturation if we wanted our planets to be more interesting, but since we control the colors directly, there's not a whole lot of reason to do that. We could increase the contrast a little bit. I think, to be honest, I think a little bit of extra contrast might be good. We're going to go ahead and leave all of the channel mixers set to fixed. We're not going to worry about it too much. This should work out fine. I think it looks pretty good. Yeah, filmic color grading is great. If you haven't switched over to using it in Blender, you should. Because it lets you get much better lighting without any extra work. He likes the hot planet very much. Yeah, so do I. And you know what? I haven't even added cities. So the point of this game is that you're going to be adding cities to these planets. So once you've done that, they glow in the dark. And that's kind of the point. The only problem is I've got to figure out why the planets are stretching before I can let you add cities, because it doesn't really make a whole lot of sense. But let's go ahead and take a screenshot of that. Aboz says he likes the hot cracks. Streaming hot cracks. Let's go ahead and regenerate these planets so that I can get myself some more pictures. We can adjust the exact size of this window. Oh, that's an almost identical planet. Did I hit run rather than reset? I bet I did, because it's random, you know. Let's go ahead and adjust this camera until we can see the planets. I'll have to turn off the post-processing stack when I'm doing anything complicated over here. Well, let's go back over to this hot planet and re-increase it. Because it is a little bit small. I've been streaming for 3 hours, and I'm going to be finished up real soon here. You can ask me some final questions before I sign off, or not. Oh, dang it. I accidentally clicked on the Twitter side of the screen, and now it stopped working, because that's how it works, you know. It closes down the thing you were about to post, and your screenshots go away. God, that bloom really does help, because it washes things out based on how many neighbors it has. So that means that when there's no neighbors, whoa, that's interesting. You know what happened? It got overwritten with a different color, but the new color didn't have its emission value turned off. So it got overwritten with a dark color at a moderate emission level, and the result is that we're now emitting like a dark gray. That's cool. I didn't think that would happen. That's really neat. That was probably one of the moon things that I put on, because I had a small chance that the hot planet could get a moon value applied to the top. That's probably one of the moon values. Ooh, cool. One more set. The Experiments says, what is this game? It's a Game Jam game. You're going to be able to click on planets and put cities down. Now that I've got the the hot planet's looking so good, I need to really improve the rest of the planets. And the way to do that is to add in proper normal maps. Put in some ProcGen. And then let's go ahead and look up normal maps again, because I know there is a really easy set of code. I suppose you will upload the game at the end of the jam, right? You bet. I can't upload the raw project if I use any copyrighted elements, and I plan to put in some music that's going to be copyrighted. But I can certainly upload the actual game. Still, we're going to go ahead and say height map to normal map. Code. Each pixel represents a vertex on the grid, so intuitively it is normally determined by the neighbors. Given a function, you assholes, I want a C code, and you're giving me math, like actual like curly Q math. That's not how you do code. But they're not doing what I want them to do anyway. Height map to normal map, OpenGL. He's recommending a 3x3 Sobel filter. Your normal map should be 4 times bigger than your height map. Not going to happen. So according to this, he's doing calculate normal int u int v. No, he's not talking about something that actually works. But basically, he's working out the UV offsets and then just creating a Sobel filter. Okay, I see what he's doing. That's actually really straightforward. Let's go ahead and use his method. I'll program it in right now. So basically, he's just taking samples in a 3x3 grid around our pixel, and then he's giving it X and Y values based on that. So that's not too bad. We're going to go over here and create a function to do that. So public void alpha to normal. And then we'll take in a pixel list. We'll just not even do that. We'll just do it with the pixels we know are going to be. Converts the height map into a normal map, overriding RGB using the height A and a filter. So what we're going to want to do is go through every single point in this normal map, and x equals 1, x is less than whatever the width is, so width minus 1, x plus plus, for int y equals 1, y is less than width, or height, minus 1, y plus plus. And then we'll just go ahead and say alpha to normal x, y. And down here we'll do it again. Public void alpha to normal int x, int y. Now the problem is we are actually skewing the entire image. And this will definitely mean that the normal maps are going to be weirder up near the poles. I don't really care about that right now. So what we're going to want to do is get a grid, a 3x3 grid based on our current position. Now the easiest way to create a 3x3 grid is just to create an array of 9. Except for it's not a color, it's a float. So we're going to have an array of 9 floats, But the problem is if I do that, I'll be allocating an array hundreds and hundreds of times. So float grid equals new float 9 grid. So what we're going to do is we're going to fill this grid up with values. So for int so sx and sy, int x equals sx minus 1, x is less than or equal to sx plus 1, x plus plus, and then for int y equals sy minus 1, y is less than or equal to sy plus 1, y plus plus, and that's always going to be true due to the way that we are doing this. And then we'll just go ahead and keep track of the index, int index equals 0. And this is actually backwards. We'll just put the y outside and the x inside. And then we will just say grid index. I guess this shouldn't be floats, it should be bytes. Grid index equals, and then we're going to grab the height map pixels, and then we need an index, which is going to be x plus y times width dot a. So now we have a grid of all of our pixels, and what we're going to want to do is create a an amount of delta both on the x-axis and the y-axis to show us the amount of flex we're going to need on those planes. I think that's going to work. So not 100% sure, but let's find out. So if we do that, then we're going to want to have int x delta, and then what we're going to need to do is calculate out the amount of difference between us and our neighbor. You know, I could do this without taking a 9 grid. I could do it with just taking a very, very fast and simple. Yeah, okay. Let's do this cheap and easy route. It's not going to be as good, though. No, we do have to use the 9 grid. So in order to do this, we're going to want to have the grid of, you know, I can replace the 9 grid with a 9 grid of deltas from the middle value, which would actually be cheaper. So these should be ints rather than bytes. And what we'll do is here, when we grab this, we're going to want to have the actual base value equals height map pixels x plus sx plus sy times width. And then here we'll just subtract base value. So when it's higher, that means it's higher, and when it's lower, that means it's lower. And then we can just add these values together in order to get a proper setup. So we're going to want to find the grid elements that we want. So we're gonna weight them. First, we're going to add in all of the grid elements that matter less. So that would be 0, and then grid 1, 2, 0, 2, 6, 7, 8, 6. So 6, right? 0, 3, 4, yeah, 6. So that's the left 2 grid elements. And then we're going to subtract the right 2 grid elements. And then we're going to x delta divided by equals 2. And then we're going to add in the critical elements. So x delta plus equals grid 3 and minus grid 5, with grid 4 being the middle grid, right? 0, 1, 2, 3, yeah. So grid 4 is in the middle, and the rest are arrayed around it. So then we have an x delta, and we want this x delta to be our our value. So we're going to want to add in 100 and, what is it, 256 divided by 2, 128. If x delta is less than 0, then x delta equals 0. If x delta is greater than 255, x delta equals 255. And then we're going to want to assign this to one of the channels, which I actually don't know which channel is which. Normal maps have specific channels applied to R, G, and B. So according to this, red is the color that we're looking for. So we're going to go ahead and say that height map pixels, I guess we'll want, wait, that's inside of this? We're doing this in the wrong place. I'm an idiot. Outside of that, there we go. We're going to want to have index equals 0. Yeah, so down here we'll go ahead and say index equals sx plus sy times width. And then we'll reuse that as our coordinate. Well, I guess we don't have to. It's going to be, I guess it'll be a little faster, right? Yeah. So we'll go ahead and say height map pixels index.r equals x delta. And then we'll repeat the process for our y coordinates. And I'm going to go ahead and actually type it all out because it's easy to make a mistake. So grid 0 plus grid 2 minus grid 6 plus grid 8. Now the problem with this is that I might have that backwards. We'll find out real quick, I'm sure. And then we'll go ahead and y delta divided by equals 2, and then y delta plus equals grid 1 minus grid 7. And then we'll go ahead and do the exact same thing we did up here with this part. Y delta, y delta, y delta, y delta, y delta, and green, I guess. Now I don't know whether or not blue even matters. I think that it's normally just set to 128. It might matter. I don't think I've ever seen it matter. I'm not very familiar with normal maps. Since I normally just calculate them using a built-in system. Let's go ahead and check something before I go too further here. No, okay, so let's see whether or not Unity has a built-in Unity normal map function. How do I create normal map? How do I create a normal map using a script? Stores the exported image. You can export it. So that's actually not as good as what I'm doing now. But it does tell me that the blue is not as... Wait. Yeah, the blue is just set to 1 according to this guy, which is 255. Interesting. And then the alpha is set to y delta? That doesn't make any sense. Abaz liked this stream. That's good, thanks. It's always nice to hear. So what we're going to want to do here is accept that height map pixel has changed, and then once we reach the end of the alpha to normal, we're going to want to do the height map. Oh, we don't have to. We'll do the alpha to normal before we apply the height map, obviously. So our height map is going to be at the end of process map right here. So we're going to go ahead and alpha to normal it, but first we're going to want to do this after our show height map. Now the reason for that is so that we can apply the raw height map pixels, which include red, green, and blue channels, as the albedo when we're asked to. And that should maybe work. Let's find out. We'll go ahead and take this Earth-like planet down to a size that we can live with, and then we'll run it. Barf. Okay. So int base value is height map pixels dot a. Thank you. Cannot convert int to byte. I know you can convert int to byte because I'm not an idiot. There we go. Let's try running this. And let's take a look at the height map. Well, that looks promising. So once we have this, what we need to do is actually staple it to the texture using the exact same thing that we used here. Right now we're using parallax map. We're going to want to use normal map as well. In fact, we don't need to use the parallax map. Alboecha says, you're basically taking a 3x3 sample and calculating where the sample is higher, first left, right, then top, bottom, and then you apply it to the normal, right? I don't have to apply it to the normal because the normal map has these values built in. So the idea is that I'm storing how much in tangent space, how much x and y offset there is to the standard normal. So the red and green channel are applied to the local space x and y when it happens to render. So I don't have to worry about the x and y coordinates lining up properly or anything like that, because that's the nature of a normal map. The reason they're a pain in the ass to calculate is because you're basically calculating things out in local space, but you might not know how to do that. So anyway, let's go ahead and try this on for size. That doesn't seem to have done anything. I spelled normal map wrong, didn't I? Normal. There is no normal map. Okay. Bump map. So it's fucking called bump map. Like I said, they changed the name, but only for the display. Great. If you're wondering why I get bump map and normal map confused, it's because Unity doesn't know what they are either. Come on. That should have worked. Oh, it did work. It's just not properly doing anything. So I think that the problem might be that it's too subtle, but that's not what I expected. So what we're going to do is go ahead and multiply this by a value before we go any further. X delta times equals 2. We'll just go ahead and start it off with 2. Y delta times equals 2. Now at this point it's based around 0. So multiplying it by 2 should work fine. When we add 128, that's the last step. So we can't multiply it by 2 after that, or else it would always be pointed in a funny direction, which would be dumb. So you can see that there are definitely values in this, but for some reason, it's not showing up in the actual planet height map. Well, there's the height map here. That's the height map, not the normal map. Yeah, I mean, look, it's a normal map, so why isn't this... So the weird thing I'm seeing here is just that this is not actually seeming to show any sort of normal on our normal map. If I go over here into the Earth-like and I actually clear this normal map, there's no change. Well, I actually can't clear the normal map due to the way that it's working. But if I were to rerun this, I'm not seeing a difference in any of these values. There's no... I'll take out tint by height. There doesn't appear to be any normal map-ishness in this. Even though I'm calculating out a normal map and assigning it, it doesn't seem to be having any effect. That's strange. Maybe it doesn't work in scene view. Normal maps work in every view. They're super, super basic. Fundamental. What I could do is I could just randomly create an image, make it into a normal map. And we'll go ahead and... Ooh, that's certainly a more interesting normal map than the one I created. And you can see that it's got a radically different set of colors attached to it. So I'm not at all sure that this is... I'm not at all sure that I've chosen it correctly. So this is very much red. And then maybe it's I got the channels wrong, and it's red is supposed to be one and the other ones are supposed to be other colors, but that's weird. That shouldn't be the case. Aboichi says he's never seen red normals. Yeah, neither have I, which is why I don't think that's the case. I think that that's just because it's transparent and it's all screwed up. Let's go ahead and create a new value here. Once again, I think I created it at ridiculous bigness. I did. Pixels, please. Better. And we're just going to go ahead and draw some values that will give us some normal mappy goodness. That's fine. So we'll go down here to the normal test and tell it to be a normal map. Ah, that's what I expected to see. So this is very similar to what I've got, except that my divots are not as pronounced, and maybe that's an issue, but it shouldn't be. For some reason, however, this is not taking. If I apply that normal map, you can see that it really, really cares. Over here, you can see that this is like crawling with normal map nonsense. So it renders a normal map fine, but for some reason, there's something really weird going on. So does it have to be labeled as a normal map? Is that because it might be that it has to be labeled as a normal map or something stupid like that. Let's find out. So if we hop on down to where we create that texture, it might be possible that it is get pixels, get raw texture data, map, resize, set pixels, update external texture, NISO level, dimension, filter mode, map bias, texel size, wrap modes. Okay, so there's nothing in here that says that it has to be a height map or a normal map. However, there might be something in this where like it only works with mappable normals or something. I don't think so though. I think it should be fine. If we take a look, this is RGBA 32-bit, whereas this is DXTMM, and that's probably the difference. The compression needs to be different, probably. So if I can change this over into, is that DXT or DX1? I can't tell. There's pixels in the way. DXT. If I change the height maps format, DXTNM. There is no DXTNM. If I change it to DXT1, it's going to be slower to read and write, and that's going to be an issue. And mipmaps are enabled on that. I could just turn this on as well, but that's going to screw things up. Like, this is going to really break shit. Let's see whether or not mipmaps, turning off the mipmaps, whether that breaks the... No, so I can leave it with mipmaps off. But I'm not at all sure that this is going to work. Let's go ahead and clear this out and try it again. Okay. Well, that's certainly different. At least now we know that the normal map is, in fact, doing something. It's just... Okay. Wait a second. So when I run this and apply the normal map... Okay, so when I'm actually writing it as DXT, it's actually not... It doesn't compress afterwards. It barfs. Okay, so if we wanted to have it compress, we'd have to do it otherwise, but I don't know why it would be necessary to compress it. That's really interesting. It shouldn't be this hard to make a normal map. So why is this such a pain in the ass? If I change this to no compression, it still works. If I change it to crunch compression, it still works. So it's not the compression that matters. As far as I can tell, none of this stuff should matter. And here I do have values showing up. This is when I printed out vertical stripes on the planet. So if I run it again, so we definitely have something going on. I don't know if you can see that on YouTube, but there is like a shimmer moving across the surface of the planet. That usually means that your normal map is not a normal map. And what you're doing is you're pointing normals randomly off into like the X dimension or whatever. But the thing about this that's strange is that it only happens when I have a normal map already assigned to the planet shader. When I don't have a normal map assigned to the planet shader and I attempt to apply a normal map, it doesn't work. But when I do have a normal map applied and then I attempt to apply a different normal map, it does work, which is super weird. But as far as I can tell, this off-center normal map is correct. This is not the random normal map that we put together. It's definitely aligned with the hills and stuff. So it's just a matter of making this work with the correct colors and stuff. So if we take a look at this height map, this is how it looks right now. And for some reason, this is causing us trouble. It may be because the color is not set up right. So let's go ahead and just change some of these colors around, see whether we can come up with a color that it likes. Nope, still broken. So do I not want to multiply by 2 or something? Oh, I did that too fast. I didn't give it a chance to recalculate. Now try it. No change. What happens if instead of writing this, I just write 128 to all channels? Or 127, whatever. What if I just make it a gray normal map? I don't think it's supposed to be gray, though. I think this is supposed to be 255, because they're always blue. Do you think the alpha matters? Do I have to set the alpha to... I saw someone setting it equal to B. Or equal to G, rather, which would be... I don't know why that would be, but I can try it. Invalid text. That's actually long dead. That's not a thing anymore. You don't have to worry about that error. It's from back when I was experimenting with texture formats, thinking that might have been the problem. Okay, so once I set the alpha, it actually seems to work. So maybe the problem was that the alpha was screwing it up. So let's set the alpha to 255, and then set these guys up. And we can check and see whether or not that alpha is supposed to be the blue channel. It would, I mean, the green channel. It'd be a little strange if it's just supposed to be a duplicate of the green channel, right? Oh, I need to wait until it's Okay. Well, that's definitely wrong. Fascinating. So I think that there is a reason why this is... Maybe it's supposed to be... I can't... Did I actually see that, though? Was it something more complex? New color. Oh, this guy says that it's supposed to be X delta Y delta 1 1. Interesting. Okay, so let's just play around with these values until we find some that work. Well, that actually seems pretty decent. I can't tell whether it's actually doing anything, though. If we take a look, it's pretty Spartan, pretty spare. Let's go ahead and multiply these. Well, we're definitely getting normal maps, and I think they are, at least on the y-axis, backwards. They might actually be backwards on both axes. So what we're going to do for that is we're just going to go and replace these values with 6, 8, 0, 2, and then 7, 1. We'll wait for it to recompile rather. Now we'll run it again. And we should see that these pop. Yeah. So that is interesting. I think this is actually correct now. Is that really supposed to be the second? Is this really supposed to be blue twice? I mean, Y twice? Seriously? Is that really true? That doesn't seem to make any sense. Normal map alpha. Alpha channel in the normal map. All normal maps are stored in two-channel format, AG, alpha green. Oh, okay. They're using alpha and green rather than red and blue. Well, that's a little strange, but I can do that. So if it's alpha and green, then we can simply set this up to be X, right? So let's go ahead and make a note here. Apparently, it's alpha and green channels. So if we're going to do that, then this will be alpha. And then this will be green, and then R and B can both be 255 or whatever, right? That explains why when I set alpha to 255, it was that weird sheen. Because if it's a weird sheen, that means that it's always being pointed in a really, really weird direction. Oh, okay. Well, I don't think it's working anymore. I think it is now broken. This pink normal map. Well, this was done in 2006. I wonder whether or not that is, I mean, Unity. Unity normal map channels. How to create and use bump maps. Surface normals, blah, blah, blah. Blah, 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 blah. How do I get or make normal maps? Why the bluey purple colors? RGB values are used to store X, Y, and Z, with Z being up. The values in normal are treated as halved with 0.5 added. An RGB value of 0.5.51 results in a hex vector of 001, which is up. So according to this, it isn't like that, and it is RGB. So that's okay. I can play this game RGB with an alpha of, I don't care, anything. Da 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 da. At the time of writing, they only use alpha and green channel for normal mapping, storing the X fraction in alpha and the Y fraction in green. But this was also written in 2011. Huh. Well, we have a new material since then with a new rendering channel, so I think that that's probably obsolete. Now you can see some normal mapping here. Well, we got quite a normal map happening right there, don't we? We'll deal with that later. I can't actually tell whether or not this normal map is working. It looks like it's working. I mean, this feels like it's a more planety planet. If I turn the main camera's post-processing back on, yeah, it's definitely working. Look at that. The only question is whether or not it was correct in all directions, and it seems to be. Now, one of the issues we've got here is that I'm doing it in 3x3, and it looks like that might not be foggy enough. It might be a little bit too sharp. So what I really might want to do is, after that, I might want to blend it or something similar, but that sounds annoying. So let's see, close down a whole bunch of stuff here. Elboechi says that normal maps and bump maps are different things. You think so? I think so too. These normal maps are definitely working. But the problem is that our Earth-like planet... Oh, it's just low res. If we bump this up to the full size, we should be able to get a more full-size set of elements, right? Grind, 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 grind. Didn't I run it? Oh, I did. There it is. And you can see that's actually substantially better. Good, good. Everything seems to be working. The only thing left for us to do is to change our hot planet big patches to create just a little bit of extra height, or not. I basically, at this point, the noise is not creating any appreciable depth around the edge. So what we're going to want to do is add another channel crusher. Which will crush the red back into the surface. But we're going to be doing a remap that's really, really aggressive. So basically, we're going to remap almost everything to this tiny little corner of the map. And that should work. Yeah, that should work. So we're going to copy that. And then we're going to paste that into all of the ones that have patches. There we go. So now let's try that on for size by recalculating our hot planet. those creases that we pulled are a little bit excessive, but that should be okay. All right, there we go. So now we've got a little bit of depth to it. Now I think that hot planet needs to have a better surface. It's not very modeled, but the real problem is the depth of these carvings is rather exceptional. Those are not hot planet carvings. Those are moon carvings. So what we're seeing there is a moon element that we might want to adapt into a hot planet element a little bit better than we have. Elboechi says that the normals with the lava rivers probably need to be a bit more pronounced. That's exactly what I just did. So we are on the same page. But what we need is to create a slightly better set of hot planet results. These details with the cracks are not going to work out. These cracks are too mooner and not hot enough. So we're going to need to remove them. Ooh, that's interesting. Let's go ahead and readjust the camera so that we can see more planets here. Actually, I'm going to go ahead and adjust this a little bit differently. I'm looking in the little window in the lower right in case you're wondering how I'm doing this. I'm just ignoring the bright white screen that I've got. But it looks like I won't be able to do that anymore. So let's go ahead and just turn off the post-processing and then move these moons into a location where I can see them. I can't tell which of those moons I can see and which of those moons I can't see. But I have a feeling that I need to move both of these moons like this. Yeah, there we are. Good enough. Let's go ahead and turn that post-processing stack back on, go over into our game environment, and recalculate all of these planets. Now with the new bump mapping. Stretch. Well, that water is very ripply. That's okay. We'll work on it. So if we look at that bright white glow, that's exactly what I wanted to do. Now with emission and bump. ProcGen Jam. Let's go ahead and move this moon a little bit on the z-axis. No, there we are. This moon a little bit on the z-axis. Let that grind for a little while. We're not going to be doing this kind of stuff in the game proper, so... Phenomena. Phenomena. Okay, so I don't like any of those planets. We'll just do them all again. And we're about to stop here. I've been doing this for frigging ever. And this is definitely a good place to stop. I'll probably stream again tomorrow and work on making planets clickable. But for now, I don't think I want to. I have been streaming for ages and ages and ages and ages and ages. Actually, those cracks look like crap on the moons, too. I might just need to change how those work. Grind. Oh, look at that huge glowing patch. That's pretty damn cool. And one more. Come on. Boom. Wow, that Earth-like planet is mostly desert. No, you know what? I don't like any of those. Let's go ahead and recalculate this one more time. Did I screw that up? No, I didn't screw it up. Do 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 do. Phenomena. Boop, 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 boop. Phenomena. Boom. Interesting. We got some very watery planets this time around, but that's okay. All right, so thanks for keeping me company. I can't believe how many of you watched. It was like 4 or 5, which is quite a few. Alboechi says he knows which planets he wants to encounter in the game. Well, the idea is you'll start with moons, and then as you sell off the planets, you'll be able to afford better settlement areas. And the hot planets are definitely the most expensive because they have the hardest to settle environments. So basically, of the planets that I've created so far, you'd start with moons, and then you'd go to the garden planets, and then you'd go to the hot planets. You'd go to all 3. You wouldn't just go to hot planets or whatever, but each settlement costs you cash, and they're going to be orders of magnitude more expensive. Anyway, that should work, and it should be easy to add in some pixely cities, settlements. But in order to make this really look good, I got to figure out why the heck the stretching is happening. Now, this crease, I can actually fix that. I know exactly why that's there, and it's not a big deal. The stretching really only happens up in the north and south areas, which means it's definitely based on how I am pulling the x-axis together. And what I might do is just really, really change how we do the soft merge, but leave that for later. I will see all of you folks some other day, probably tomorrow. And otherwise, thanks for stopping by. Where's the stop button?